the climates in which they live. And what I'm going to do today is I'm going to talk broadly about urban climate. I'm going to place it inside climatology studies, generally speaking, including climate change at the scale of the world. So I'm going to switch over now to take control of the screen. Let's start, as usual, with geography. You, of course, are in Kolkata. Let me just give you a sense as to where I'm located. I'm located in a completely different part of the world, a different type of city. Both Kolkata and Dublin were effectively run for years by the British people. It was part of the Empire, the British Empire. And that means that there's lots of things that you see in our city that you probably see also in Kolkata in small sections of it. The city itself is quite small. And in fact, I'm located right here. Like, where's my building? Yes, my building is located just here. So that's where I am at the moment. So it's morning time here, it's afternoon time there. So I'm going to talk for about 30 minutes now about urban climatology. And I've started off with a picture here. The picture here shows a suburb of Mexico City. There's no more radical transformation of the landscape than has happened inside urban areas. This particular image shows the occupation of the landscape draped over topography. It shows all the buildings. Of course, this is one of the major changes that we associate with urbanization. It's a replacement of natural surface cover by manufactured surface cover. So you're looking at here as individual buildings, which are hard, three-dimensional objects that affect the wind. You're also looking at paved landscapes that prevent the water from going into the soil. You're looking at relatively small amounts of vegetation. And of course, what's hiding here, what you often don't see, is the occupation of this landscape. Be it all these roads, be it all these houses, or all the piping systems that make the connections to make it an urban system. So hiding here are transfers of people, traffic, transfers of water, and of course, as a consequence, transfers of waste energy and heat into the overlying atmosphere. So what I'm really interested in how decisions about, whether they're made consciously or not, by putting buildings close together and altering the landscape to make cities, how it affects climate. Now, what you'll see, of course, is that the types of decisions that go into making climate occur at all sorts of scales. We make decisions about how we live in individual houses, about heating systems and cooling systems. We make decisions about how we commute maybe to work, whether we cycle or walk or take a car or take a bus or take a train. Then there are all those accumulated decisions at the scale of a neighborhood. And that neighborhood might be a commercial neighborhood, it might be a mixed neighborhood. It might be nothing but warehouses. Then, of course, when I put all the neighborhoods together, I make a city, and a city is a very complex entity with all sorts of connections between where people live and where they work, where they go to school, etc. And of course, cities are fitted inside nation systems, fit inside regions, and taken together, of course, we get entire sets of decisions that accumulate and affect the climate of the planet. In fact, it's not possible to divorce any of these decision-making. So I'm going to draw upon essentially three perspectives. The first on the left-hand side is one you're probably very familiar with. It's the most recent IPCC report, which has a global perspective. Then there has been an attempt to try and take the information in a global perspective and translate it to an urban perspective. So I've shown you another one here, which is called Climate Change in Cities. This is a second assessment report of the Urban Climate Change Research Network. It's fundamentally associated with trying to connect global scale climate to the city scale. And the one on the right-hand side is a book that I was associated with, which is specifically about the climates inside cities. The big challenge we face is to connect all these things together, because although cities make up a tiny proportion of the landscape of the world, they are the significant drivers behind climate change at regional scales and climate change at global scales. So I'm going to briefly talk about global scale climate change. Then I'll talk about urban scale climates, that's where I'll focus. Then I'll talk briefly about applying it, that knowledge. Then I'll ask questions about what gaps remain. So what would any science need in order to regard itself as mature science? Well, you need observations. That goes without saying. One thing we'll see is that weather stations are hardly ever placed inside cities. The consequence is we know very little on a routine basis about how cities have affected weather and climate. Most of the information we get for stations which are outside the city. We need a framework, a logical framework, so we can do analysis. We need to understand the process, and ultimately, if we knew all those things, then we could actually construct models. We need to have a conversation. So if I talk about Dublin, you talk about Kolkata, we have to agree about what we're looking at. We have to agree when I describe a landscape that you say, oh, I don't know what that landscape looks like. That's the only way you could translate the ideas into the practice. And of course, having scientific knowledge is of limited value unless you actually have an ability to turn it into rules, tools, policy, etc., to apply it so we can actually get the climates that we might want. And ultimately, of course, we have to be able to evaluate whether the decisions we make on the basis of scientific knowledge actually have any value. I'll show you two examples here on the right-hand side. They both come from America. They're both associated with trying to manage urban heat. The one on the top is the Green Roof, which is located in Chicago. Chicago is taking a big push toward these types of roofs. And the one down below is quite a simple intervention, consisting of painting rooftops white in New York. The idea, of course, in both instances is to try and regulate the amount of heat that goes into the building that causes heat stress. So here's the structure of global climate change. It places risk in the center of three intersecting areas: hazards, exposure, and vulnerability. And of course, what's driving the hazards is natural variability and anthropogenic climate change. And what's driving the response to this are things like the pathways we take, the decisions we make on foot of the science, the adaptation and mitigations, and then how we actually govern. You notice that the thing that actually connects these are emissions and land use change. But the big one that you can see emphasized there is emissions, not land use change. This is quite interesting because at an urban scale, it's probably the reverse. At an urban scale, it's probably land use change that has the most dramatic impact on climate, and emissions less so on climate. But at a global scale, it's the reverse. And part of the reason for this is because, in effect, cities make up a tiny proportion of the landscape of the world. But that's where everybody's concentrated, and that's where all the action is. So that's where all the emissions are coming from. So we have this issue that constantly comes up about how do we manage cities so we can manage the global climate. So if I take cities themselves, they're affected by global climate change. That means we have to adapt. But if I take all the cities together and all the emissions, then they affect the global climate, in which case we talk about mitigation. So Dublin's going to have to adapt, simply because all the decisions made by all the other cities in the world most likely cause some level of sea level rise, which will affect Dublin because it's located next to the coast. That's a given. Mitigation, however, is about Dublin making a choice not to emit or to emit less, simply to try and prevent climate change happening, not only in Ireland, but also elsewhere. So mitigation is really a sort of social idea, in the sense that we all have to pull together if we want to mitigate. Whereas adaptation is almost a selfish attitude. To adapt is simply to protect yourself. So some obvious things. For most people on the planet, the urban environment is now the norm. We passed this boundary just before 2010. There are now more people living in cities and urbanized areas than are living in rural areas. And this trend is going to continue. So that means that in terms of risk to individuals, the risks are going to be greatest in cities, simply because there's more people living there and because cities happen to be located in quite risky environments. The map above shows population density. Map below shows carbon emissions across the planet. What it shows clearly is that the big wealthy cities of the world are the drivers behind carbon dioxide emissions. What you see from this map, inevitably it's out of date, is that many of the big cities in Africa actually have a very small imprint on the global climate. But the cities of the Western world, particularly those of Asia, Europe, and North America, have a big impact on the global climate because they're major emission sources for carbon dioxide emissions into the atmosphere. So if I want to try and mitigate global climate change, it would be a good place to start that start at the scale of the city, which are relatively small entities, and which have good, at least by comparison, they have good planning practices that can actually adjust themselves. Where is future population growth going to occur? Well, it's going to occur in the hot climates. So the climates, say, for example, of North America and Europe, most of them, and much of China, according to the Köppen climate classification, fall into this range of what they refer to as sea climates. Sea climates are moderate. This is where most people have lived in the past historically, for very obvious reasons, which is that sea climates were extremely productive. But the big big population change in the future is going to occur in the A climates. The A climates are tropical. Now, if you think about what this means we're going to see a rapid shift in the demands of cities in the future, away from cities that probably need heating during the winter, towards cities that need cooling during the summer. Here's an example. This is a classic chart that shows outdoor humidity, outdoor temperature, and then it plots what's referred to as indoor comfort in relation to those two properties. So this basically tells us about what it would take to be comfortable indoors. What I've plotted on here is a series of cities, New Delhi, Khartoum, Singapore, London, Moscow, all of which have different climates. Now, if the objective of buildings is to make them comfortable, that means that ultimately we're going to have to shift the outdoor climate to an indoor climate in each of these places. The effort required in London and Moscow is largely associated with simply warming the air. The effort required in parts of Delhi at given times of the year, and in Singapore and Khartoum, is going to be to cool the air. So that means we're going to see a big shift in the future away from heating systems toward air conditioning systems. Cities are unique. Every city has a slightly different topography. It's located in slightly different terrain. It's got slightly different needs. It's got a different type of industrial base. It's got a different cultural setup, which means different types of buildings, different types of living arrangements. But they do share many things in common. Most cities are located on fertile land. Fertile land is located at lower elevations. That means most cities are located in basins and valleys. Most cities were set up for trade, which means they're located along rivers. It means that they're located next to the coasts. This means that they experience the same types of local topographic effects throughout the world. Beijing, for example, is located in a basin. Santiago is located in a basin. Mexico City is located in a basin. So this means they, simply because of the location, they inherit atmospheres that are inherently stable. So many of the air quality issues that they face are simply a matter of the fact they've chosen the same location. Here's the point. Cities have tended to choose the same locations, which place them at risk of flooding, at risk of poor air quality, at risk of sea level rise. In fact, this is made explicit in the IPCC reports. Many global risks of climate change are concentrated in urban areas. Steps that build resilience and enable sustainable development can accelerate successful climate change adaptation globally. Heat stress, extreme precipitation, inland and coastal flooding, landslides, air pollution, drought and water scarcity pose risk in urban areas for people, assets, economies, and ecosystems. Not surprisingly, risks are amplified for those people who are exposed and who are vulnerable. Not surprisingly, an almost alternative politics is set up around the globe, which is trying to tackle climate change at a global scale by focusing the efforts on the cities. So we're seeing a shift in how global climate change might be managed away from national bodies down to the scale of cities. Okay, so let me tell you about the development of urban climate. Up until the 1970s, most considered that the only unambiguous climate change that could be attributable to humans was associated with cities. And the reason for this is for about the last 200 years, we've been studying climate impacts in cities. But we've been doing it in a very idiosyncratic way. So, for example, here's how we set up our weather stations to globally monitor the weather. There are typical weather stations located over grass. They're far and distant away from any source of contamination. On the left-hand side is a picture of Dallas. So there's where we live, on the left-hand side, but it's where we measure. Somehow I have to be able to connect the two things. So what do we associate urban climates with? extraordinary climate variation over very short distances, enhanced heat stress, profoundly modified hydrology, and of course poor air quality. All these things combined. The best known of these is what's known as the urban heat island. The urban heat island has many definitions. The most commonly measured urban heat island is an air temperature. Air temperature measured at about chest height in amongst the streets of the cities. And what it shows clearly is that every city around the world has an urban heat island. And one of the big areas for urban climate research in the past is to discover the reasons as to why, the timing, and the magnitude of the urban heat island effect. Well, we've known about this for a long, long time. What urban climate science has tried to do over the last 50 years is try to assemble this knowledge into a coherent framework. What drives urban climate? Well, first thing to remember is that urban climate is driven at processes that operate at different scales. There's a scale of the entire city, there's a scale of what we describe as a neighbourhood, and there's a scale of which we describe as around the individual building. The drivers are fundamentally associated with aspects of urban form, what proportion of the landscape is vegetated, what proportion of it is paved. They're associated with geometry, morphology of the buildings, that's the height of the buildings, the dimensions of the buildings, the spacing of the buildings. And it's associated with the manufactured fabric that we use, the glass, the steel, the concrete, asphalt, etc. I'll call all these things form. In other words, if I was to build a city and then leave it, I'd still be left with form and it would still have an urban climate effect. But cities are occupied. And occupation means that people need food, water, energy, etc. to go about their daily businesses. This is what we refer to as urban function. An urban function associated typically with building sectors, industrial sectors, transportation sectors, all of which have a constant demand for energy resources. And then when that stuff is used, it gets delivered into the atmosphere, to the soil, to the water. So that's how we get anthropogenic air quality problems, direct heating problems, etc. It's because the city is actually functioning. So the two aspects of the city. Urban function is often described as the metabolism of the city, a bit like the human body. So let me just show you form. There's land cover on the left-hand side. That's Central Park, looks like a natural feature. The building in the center is the UN building in New York, all glass. The one on the right-hand side is Hong Kong, which has extraordinary geometry, very narrow streets, very tall buildings. You can clearly see that the climate that you experience inside the city street there is completely different from the climate you'd experience in any other location. And if I mapped out all those aspects, there's a picture of Tokyo from the atmosphere. Cities form this extraordinarily complicated environment. You can see why, for the most part, meteorologists have avoided cities. Where do I make measurements inside this environment? It's next to impossible to determine a representative site. Urban functions, the traffic, the buildings, the industry. The buildings, you can't actually see it there because the emissions aren't obvious. But of course, in order to heat or cool a building, to run the energy, to run the lights, to run the computers, there are enormous drawdown on energy resources. About 30 to 40% of all the energy on the planet, primary use energy on the planet, is used to heat and cool buildings and to maintain its functions. In many cities around the world, the energy being used inside cities is split approximately into thirds. About 1/3 traffic, 1/3 for buildings, and 1/3 for industry, including energy generation. And again, if I was to map out these aspects of metabolism, here's a great picture from Cairo. I'm sure you could take pictures like this throughout Kolkata. It shows every single aspect. There's people here who are exposed to pollutants associated with cars, buses, motorbikes. There's food courses in here. There's buildings. The buildings have the windows open, so the air is going back and forth between the indoors and the outdoors. This is all associated with the actual occupation of the landscape. And these things are linked together. There's a very, very well-known image about how we should make cities more compact. And if we make them more compact, then they would simply use less energy. So here are two equivalent cities in terms of population Atlanta in the United States and Barcelona in Spain. They're the same population, but you can see the footprints are completely different. Not surprisingly, the emissions per capita for transport are dramatically different. There's one argument at a global scale for making cities more compact, and therefore by extension making them more efficient. So, urban climate science, the way it's made progress is by dividing out the processes that I've just described and seeing their effect at different scales. The three scales are the scale of the city, the mesoscale, at the scale of the neighborhood, the local scale, and the scale of in between the buildings, the microscale. So they're the three things that urban climate scientists are focused on. How do they get a handle on heterogeneity? Well, they did it by simply simplifying the urban landscape to try and look at very, very simple forms. This is a very, very famous picture from the Kanda lab based in Tokyo. They are representing the city as a series of concrete blocks that they can move about and they can test what the effect is of changing the geometry. So that's how they deal with complexity. So they try to look for parts of the city that can be described by analogy to what you see in this image. The other thing we've discovered is how to measure in cities. If I want to measure what the urban effect is at the mesoscale, I can't measure anything within the city streets. I have to go way above the city streets to record. This is a picture of an instrument that I had once upon a time in Dublin. The individual there is climbing up a pole to put an instrument on top of a very tall building. That's the only way by which I can get measurements of the urban landscape, is by simply relocating where I measure to be well above the buildings themselves. And the other thing that has happened over the last 10, 15 years is we've seen a flood of different types of models, all of different sophistications designed for different things. Some of them are simple, such as the one on the left-hand side, which is called single facet. Others are more complicated because they include geometry. And at the far end are the extremely sophisticated model, like the weather research forecasting model, which accommodates or allows you to put in information about the individual buildings inside a city. And how these models work is what they take as descriptions of the city, what they refer to as parameters. And if they have those descriptions of a city, and here's a list of those descriptions, then I can plug them back into the models here, and then I can start running simulations. So we're now at the point in urban climate science where we're actually running these models of various sophistication, and we're actually driving them using information about the types of cities, the parameters of the city themselves. So, for example, the urban cover for Dublin, many parts will be completely different from Kolkata. The vegetation fraction will be different. The impervious surface fraction will be different. So I tried to tell apart different types of cities by describing them in terms of these parameters. And if I had that information, lo and behold, we're able to connect together what happens to the urban landscape with what happens to the environment above it. So here, for example, is a whole series of measurements made mostly in the mid-latitudes, in Japan and Western Europe and North America, over different types of neighborhoods, which have different types of vegetative fraction. And what it indicates is how much energy that's available is used to either heat up the air above or humidify the air above. So it shows a beautifully simple relationship. And if I want to change the urban climate and reduce the urban heat island, the simple solution is simply to add more vegetation. Because if I look at 50% of the planet area vegetated, it shifts. Half of the energy then goes into humidifying the atmosphere. If I decrease the amount of vegetation, more of that energy goes into heating up the atmosphere. So if I want to reduce the urban heat island, that was my only criteria. Having healthy vegetation, breathing, evaporating water is an easy way to do it. Now, one of the big problems urban climate science faces is that we have sophisticated models, we have understanding of the process, but one of the big obstacles, we don't have the data. Now I'm going to introduce this is called local climate zones, which is merely a simplified description of categories of urban landscape. Now, the reason I'm introducing it is because it means that if I were to identify the type of landscape, I'd be able to work backwards to find out the types of parameters, and then put them into a model. fact, that's what this project here is designed to do. This is called the World Urban Database Access Portal Tools. And what we use is a series of techniques, a lot of which are remote sensing based, to try and classify cities according to local climate zones. Now, the project is quite big in the sense that it hopes to go beyond climate zones to talk about more details of cities. But we've started out by trying to understand the nature of the landscape over urban areas using local climate zones. So you can see we use Landsat 8, we use a software called Saga. This has changed repeatedly over time. We now use central data. We use any data we can to classify cities according to local climate zones. So what we do is we take a city and then we identify parts of the city that correspond to different types of zones. And then once we've identified particular zones associated with particular types, we take that information as training areas to try and classify the entire area according to types. The way we can do this is because there is a table, a notional table of parameter values associated with the different types. So if I graphically depict the different types of urban landscapes, presumably I can also get a handle on the parameters. So the idea is then I can map out the city and derive parameters as a consequence. And if I can get the parameters, then I can run the models. So I can do the predictions. Because the big issue has not been about the development of the models. The big issue in applying these ideas is simply to get data. Now, we've done this for many cities. This, for example, is Milan, in northern Italy. The big European cities have already been classified in something called the European Union Urban Atlas, a very, very expensive product that was produced. What it shows is ceiling cover on the right-hand side. And it does it for the boundary, the official boundary of Milan, which of course does not correspond with the city of Milan, because Milan actually extends much further outside the boundary into other areas. On the left-hand side is our estimate of pervious cover using the parameters based upon a local climate zone approach. And you can see the two are quite close. Now, the process has become more and more sophisticated over time, to the point where we've actually mapped all of Europe into local climate zones. And I know a colleague of mine, Devon Yogi, is currently in the process of deriving a similar type of land cover classification for India. So the idea now is that we try to derive the data to allow us to run these models. Okay, is the last part. I think the science is in place. It's got big problems. The problem it has mainly at the moment is we don't have the data to actually apply it. But let's say I were to apply these ideas, what are the baselines or the rules I'd use to apply urban climate principles? Well, first of all, I'd say there's a big difference between settlements that exist and those which have yet to exist. So, for example, the solutions in Dublin, which is built over the last 1,000 years, are going to be different from solutions for cities that are emerging in Africa, which have yet to be built. So, one case it might be a case of rehabilitation, and another case is to make sure that we do not cause the problems that we have in other cities. You have to link the policy to a desirable outcome, and that inevitably involves scale. Well, the challenge we have is to make decisions that will meet many, many goals simultaneously. Solve the urban heat island problem, but at the same time don't create an air quality problem. And I want to emphasize what I think is the critical role that urban design has to play in creating the spaces that people want to live in. Let me just show you a few pictures to illustrate this and the tools that you have at your disposal to make these changes. This one's supposed to illustrate action to outcome. So this is Freiburg in Germany, and what they have here is a building, as you can see clearly the rooftops of the buildings have been set aside for generating solar power. The thing, of course, that makes this work is that the buildings have all decided as a unit not to shade each other. So in other words, these buildings all have access to their own resource. Scale is important. Now, on the right-hand side is a very, very famous barrier. There was an adaptation strategy for London. It's called the London Flood Barrier. And it's supposed to protect against sea flooding and also against river flooding. So that's a type of design associated with adaptation. On the left-hand side is what I regard as a very, very strange form mitigation. This is a Walmart located in Arizona. Arizona is a desert climate. The building itself, as you can see, is a big footprint building. It's got a rooftop which is white to try and reject energy from the sun. And it's got photovoltaic cells on top, which are the black surfaces to try and generate its own energy. This is regarded as a sustainable building. But I'd like you to look at where it's situated. First of all, the space set aside for cars outside it is just as big as the building itself. And it's located in a suburban area which requires that you use a car to get there. In other words, the building is sustainable, but it drives actions, behaviours which are clearly not sustainable, and is associated with other practices that are simply not sustainable. Design is critical. Sometimes simple designs can achieve great results. Trees are the most versatile of all the tools. The picture in the bottom right-hand side, D, shows the street in Malaga. And it's a very, very simple strategy. You see it being used throughout all of North Africa. On small streets, they put these canopy overs to provide shade during the daytime. The only difference here is scale. They put a nice covering over the street to provide a shaded outdoor space. In my climate, where it rains a lot, in the upper left-hand corner are umbrellas that are turned upside down that channel the water that arrives from the sky, pipes it down into underground aquifers. Water is critical. We tend to bury our rivers in urban landscapes, but water has a dramatic impact, usually very close to where it's found, and can be used as a clever way of overcoming many of the issues associated with urbanization and cooling the atmosphere. Vegetation, without a doubt, is the best way of offsetting many of the undesirable effects of urbanization. One thing I'd say, however, because I have these debates all the time in Dublin, is that it's not a question of planting trees to offset cars. If you want to achieve air quality issues in a city, you plant trees, yes, but you also have to remove cars. There's no way trees can ever compensate for the emissions of cars. So, in conclusion, if we want to address these issues associated with climate change in cities, we certainly need to understand the full range of decision makings that are made across the scale. I think it's a bad idea to make decisions at one scale that have implications on another scale without considering what those implications might be. We still need to figure out how best to share information between places. It's not obvious. I've used my picture of a signpost in Ireland to try and illustrate this, where the signpost has lots of signs, but in fact, it's next to impossible to use those signs to find out where you're going because it's so crowded. So we do have to figure out what are the relevant issues at each of the scales now to implement them. Some of those decisions will be universal. They can be applied everywhere. Other decisions, however, will have to be specific to the location. What I would say is what I regard as the common problem. We do not have enough useful information in cities to make lots of these decisions. And I think that's critical. So this is my final slide. It's a picture back in the grand days, back in the period where we could solve everything. This comes in 1960. Buckminster Fuller proposed that we could in fact put a dome over Manhattan and create an indoor-outdoor climate that covers the entire city. Not possible, obviously. And I don't think it's possible for any individual city, any individual place to solve our climate issues in isolation. I hope that urban climate science can provide a way through for this. I think we've made big progress, but I think the future is all about the application and the evaluation of that information. So I leave it there. Thank you very much.
Thank you, sir. So we have learned wonderful things about urban climate and different urban form, its relationship. It's a comprehensive lecture you have given. And sir, we have 2 questions in the chat box. Can we take those questions? First one is from Abira Datta Roy. She wants to ask you that what are the instruments that you have shown for monitoring the climate, urban climate in your slides?
Well, there's a big change happening with regard to urban climate monitoring, which is largely associated with the Internet of Things. But let me divide it into two parts. The first part is, without a doubt, we need lots of conventional, high-quality instruments inside cities. They need to be well placed. So those instruments have become a lot cheaper now, simply because they can be made smaller and because they can communicate over the internet. But we do need more measurements about what's happening inside cities. That's one side of it. The other side of it is the potential for what's referred to as citizen science, individuals who make their own measurements and then contribute to the global good by simply supplying that information to the bodies that can make the decisions. I see enormous progress on that side, but the strange thing is when you look at the citizen science stuff, first of all, you have to go through a lot of work to try and make sure it's quality controlled. But the other part of it is, certainly the examples I looked at in Europe, you get a lot of information, but you tend to get a lot of information from the same places. In other words, it's not a random sample. So you tend to get it from the wealthy parts of cities. You see a big explosion in suddenly urban climate science data becoming available after Christmas. But people, the men in the house get presence of the weather station, and the weather station suddenly gets out in the landscape. So I think there needs to be a balance, but there's no doubt that we're seeing an absolute revolution in the technology for monitoring the urban environment. And one project I work with a student in London is that a great deal, I think, of your experience, your personal experience of the urban landscape, you're attuned to. So you can monitor the landscape and its effect on people by observation. Where do people gather? Where do people seek shade? When you walk around the city, what parts feel comfortable? What parts smell because of air quality issues? What parts don't? So you can find out an awful lot about the city by doing some simple observation, what I regard as ordinary common geography field. I can give you more specifics on the actual gadget itself. Maybe I'll just send an email to Castori about that. Yeah, if we create a green bio-village in the surrounding of a megacity, can those villages control or manipulate the city's climate? Very good question. It's a big question about scale again. There's no doubt about it, if I was to create a green village in the middle of a megacity that was polluting away, the impact of that green village and everybody else would be minimal. The real question comes as to what comes in from the outside, or what are the benefits of doing the greening. I don't think there's a simple answer to this. I guess it's always a question of the balance. If the green space is large enough, then it can create its own microclimate. In other words, it can be effectively isolated from all the areas around it. And if you think, when is the worst air quality that you get in a city, a large megacity? It happens to be when you get, strong solar insolation, with very little wind. So in both those instances, you get very little horizontal motion. So the big effect you get associated with those types of situations is the air quality up above, usually above the canopy, is dramatically poor. But in terms of your actual experience of the urban environment, if you lived in a green village, even within the megacity, your health would be dramatically improved. The question is whether doing it in a given space would help the people outside. I'd say it's got a minimal effect on the people outside that green area. Megacities create more visibility anyway. This is from Ayush. I agree. I think that trees are very simple technology. And I think planting trees have enormous impacts on the environment. They can also be planted alongside paved landscapes, which means that they don't disturb. In other words, you don't need big areas to set aside. You can plant them inside streets. But from what I can see, and all the work I've done here, is that planting trees alone won't be enough to overcome some of the urban problems. That fundamentally the air quality is associated with. Currently, it's all about traffic management. That's it. And I think one of the big questions that we face in, say, global climate science, they say what we need is more compact cities. Now think about what that means. A more compact city might mean high-rise, might mean less space for people, which means that your lives are going to be not as pleasant. So I think this is where we have to have the debate, is to what is the appropriate level of density to allow people to have decent lives and to have a decent green space. Obviously, the challenges we face in Dublin are completely different from Kolkata. But the big push here at the moment is for tall buildings, close space, more urbanization, more compact. But I'm located 53 degrees north of the equator. A tall building at this latitude has an enormous impact on the surrounding landscape. So I would much prefer they look for alternatives to increasing density that don't necessarily mean we all have to have these tall column buildings all blocking out energy from other people. If I look 100 years ago, when many of the challenges associated with public health were at the fore, the decisions they made were not necessarily to make places less compact, but they were to allow access to light and access to wind to all the citizens, on the grounds that this was simply a public health issue. So I think the challenges are trying to figure out the right mixture of compactness, so we have adequate green space, adequate access to public transport, and decent lives for people who occupy the cities.
That's also. Oh, another
How will
question.
cities achieve environmental? Well, I'll be honest with you, I think the carbon one is going to be solved probably through cars. I think electrification of the car fleet is going to make an enormous difference. I think that the big challenge is going to be air conditioning systems. And this is where it intersects very closely with things like heat stress. So we need to design cities that don't require or rely on air conditioning systems. Because think about what air conditioning systems are. It's like you going into water and putting in a scuba outfit. The air conditioning systems work by simply separating out an indoor climate from the outdoor climate completely. So I would say that the Western world needs to have a different model for comfort that allows more variation inside buildings, less restrictive temperature controls. We certainly need to address the coming issue, which I think is going to be the air conditioning issue. Because if I look at the population shifts, if I look at the development issues associated with wealth, you're going to see a rapid shift to energy drawdown associated with air conditioning. And if you look at the buildings, I'm sure you see it in Kolkata. The buildings are going up, are identical to the buildings that you see in Atlanta. They're identical to the buildings you'd see in London. There doesn't seem to be any sort of native architecture now competing for the space. They're all creating the same types of office buildings, all with glass, all with air conditioning systems.
Thank you, sir. So that's wonderful discussion we had, and we won't be able to take any further question because of the time constraint. We have to proceed for our presentations, and I'm requesting sir has agreed to stay with us and listen to our presenters, and if possible, sir, that would be like our great honor for us if you can do that. So I would like to request Dr. Bhadro, convener of this conference, to share his screen. And before that, of course, I would like to invite my co-session chair, Dr. Pratik Dash, who will be announcing the presentations coming up in this session. Over to you.
Thank you, Dr. Mukherjee. After a wonderful keynote lecture from Professor Gerald Mill, we are going to start the presentation from the participant in this technical session 4A. The first presentation will be given by Trishita Ghoshal and Debrina Paul. I'm requesting Dr. Bhadro to share the screen.
Good afternoon, everyone. I am Trishita Ghoshal, student of MSc Geography, Adamas University.
I am Debrina Paul, student of MSc Geography, Adamas University.
And today we are going to discuss about the analysis of the impact of urban growth on land surface temperature variations in South Bengal using Google Earth engine. So these are the topics we are going to discuss in our presentation. Firstly, the urbanization rate around the globe are rapid, and it has put the environmental elements like temperature, rainfall, soil and water at high risk. The urban expansion causes dramatic conversion in the areas around it. The urban growth leads to change in the land surface characteristics that in turn affect the urban microclimate by altering the heat absorption, retention and emittance capacity, surface albedo and moisture of the soil.
From the research background, we get to know that the analysis of land surface temperature and spatio-temporal variation and its impact on their biophysical characteristics are of great importance in various environmental studies and application. The urbanization growth rate in developing countries like India concentrated in particular nodes which leads to unplanned urban growth that affect LST enormously, but the analysis is often limited to small spatio-temporal scale due to computational constraints of big data. So coming to the literature review, we first reviewed the paper that discuss about the impact of LST and its associated driven factors. For example, Jones and his co-authors said that anthropogenic modification contribute to ecosystem changes, include vegetation loss, degradation of biodiversity, change of land surface and atmospheric temperature, and pollution, among other losses of ecosystem services. Then Jonerith and his co-author studies the regional relationship between surface temperature, vegetation, and human settlement assessed in the Phoenix, USA, which is a rapidly urbanizing area. Then we reviewed the work that use Google Earth Engine in LST data processing. The studies shows that Google Earth Engine is one of the best platform to analyze big data. Wang and his co-author used Modi's LST data from Google Earth Engine to evaluate Landsat LST retrievals. Then Chu and co-authors studies the influence of human modification on surface temperature for the coastal island Hainan in southern China. Their result shows a strong positive correlation between human modification and land surface temperature. The objective of our studies are as follows. Firstly, the spatio-temporal change in LST and surface biophysical characteristics from 2001 to 2020 in South Bengal, the relationship between LST and surface biophysical characteristics, and lastly, the relationship between urbanization and LST. So coming to our study area, in West Bengal, the rapid and unplanned urbanization growth is mainly concentrated in several nodes of South Bengal, particularly in Kolkata and its surrounding region. So we have chosen South Bengal as our study area. The graph here is showing the urban and rural population distribution in the districts of South Bengal. These are the data set that has been used in a study likely MODIS, LST and vegetation indices. Data set have been used to analyze LST and NDVI. NDVI is calculated from MODIS surface reflectance data set, and DMSP OLS nighttime data is used as a proxy of urbanization. All the data are retrieved and processed from Google Earth Engine.
So coming to methodology, the data for land surface temperature and other parameters were retrieved from Google Earth Engine. The data processing involved using the outlines of the study area to filter out the dataset for the area from 2001 to 2020. The calculation of annual LST statistics from the series of 8-day data, annual NDVI from the series of 16-day data, and NDVI calculated using MODIS surface reflectance data, then estimating changes in the parameters. The annual dataset. The 20 annual dataset represented individual raster for each year from 2001 to 2020. Annual average of each parameter are processed using Earth Engine, like the conversion of the data units, and plotted for the region to see the changing pattern. The parameters also plotted district-wise to see the district-wise pattern. And then, in order to analyze the spatial pattern of the parameters from 2001 to 2020, we quantified the value variation during the research period by reclassifying the each parameter in 5 years of 2001, 2005, 2010, 2015, and 2020. For the reclassification, we adopted the mean standard deviation method, which was used for thermal environmental research for the urban expansion or a land cover response to the LST. So the mean standard deviation method and the variables for the reclassification are outlined in the table to show how we classify the images of different parameters into 5 zones. There are 2 variables needed for the calculation in the mean standard deviation method. First one is the mean of the study area and second one is the standard deviation of the parameters. So the DMSP OLS nighttime light data is retrieved from the Earth engine and calculated the spatiotemporal statistics for the 10 annual data set. The annual average of the data is calculated of the year 2001, 2005 and 2010. And finally, the correlation is calculated between the LST and NDVI and LST and nighttime light. So coming to the result and discussion, firstly, the map is showing the spatial pattern of LST from 2001 to 2020, which included mean, standard deviation, maximum and minimum value of LST over 20-year span. We can see that in Kolkata and its surrounding areas, showing maximum LST value and the maximum mean value. This map is showing the temporal pattern of the land surface of the South Bengal as well as the change of annual LST from 2001 to 2020. It is shown that Kolkata and its surrounding regions lies in the high temperature zone, while the western part lies in the low temperature zone. But surprisingly, the southern Sundarban region comes under high temperature zone. In northern and northwestern part, the temperature change is moderately high, and around the parts of Kolkata in some patches, the temperature change is very high. So this table is showing the changes in the areas of the temperature. The high temperature region is changed from 15.71 to 16.94%, and there is a high rate of change in the secondary moderate and moderate temperature zone. These graphs are showing the district-wise time series of 8-day composite data of LST from 2001 to 2020. This is the graph that's showing the variation in the mean annual LST of overall South Bengal. So coming to NDVI, the map showing the spatial pattern of NDVI. So where we can clearly see that in the urbanized part of Kolkata and its surrounding region, the NDVI value is very low, and in the Sundarban region, there is a high NDVI value. So this map of temporal pattern of NDVI showing that the main urban areas lies under NDVI zone, and in the change map, the parts of Kolkata and the Sundarban region faced a high negative change in the NDVI from 2001 to 2020. And these are the graphs that showing the district-wise NDVI time series of 16-day composite data from 2001 to 2020. And this graph is showing the variation in mean annual NDVI of South Bengal. Then coming to NDBI, this map is about the spatial pattern of the NDBI. It is clearly shown that the main urban areas having high NDBI values. In this map, we can see that not only in the urban areas, but also the western part showing a high range of NDBI values that is not expected. These graphs are showing the district-wise NDVI time series from 2001 to 2020. Is about the spatial pattern of the nighttime light between 2001 to 2010, and in this part, that is Kolkata and its surrounding area having high luminosity. So this graph is showing the average luminosity value and of the 3 years, that are 2001, 2005 and 2010, and their distribution. So coming to the correlation between the LST and the nighttime light, For this, 500 points have created for each luminosity class and extracted values from the annual LST and nighttime light and computed the Pearson correlation. And there is a strong positive correlation between the LST and nighttime light. We get an average R value of more than 0.6, which indicates we can use Wales data as a proxy of urbanization, and where there is a high urbanization, the LST value in that portion is also high. These graphs are showing the correlation between the LST and NDVI. It is showed that there is a strong negative correlation between the NDVI and the LST. So where there is high NDVI value, the LST range is low there. Major findings of our study is the maximum LST is showed in the main urbanized areas, that is the Kolkata and its surrounding areas. There is a strong positive relationship about 0.67, 0.68 and 0.58 between the nighttime light and land surface temperature, which indicates that DMSP OLS data can be used as a proxy of urbanization. Then NDVI and LST shows a strong negative relation. The high NDVI value represent low LST. And the study confirms the potential application of Google Earth Engine as a robust tool in geospatial science for analyzing big data in decision-making process. We face some limitation of our research, that are uncertainty in the data set. We see that there is a high NDVI value in the unexpected region. So this reflectance of the barren land and the urban area are more or less same. It's often happen that where there is a high barren land, we get the high NDVI value. So for this reason, we ignored the relationship between the NDVI and the LST. Then the main constants of our study is the temporal coverage of DMSP OLS data, as the data is available only till 2013, and lastly the low spatial resolution of the MODIS data product. So future work of our research is to correlate the land use pattern with LST, investigate the decreasing trend of LST after 2015, also investigation of the high LST value in the Sundarban region as observed in our dataset, and downscaling the MODIS LST data product in the Google Earth Engine. So these are the reference of my study, and that's it of our presentation. Thank you.
Thank you, Trishita and Devalina. So our next presenter is Devasmita Bhomik. Dr. Bhadra, please share Devasmita's presentation.
Good afternoon, everyone. I am Devasmita Bhomik, a student of MSc Geography at Adamas University. Today, I'm going to deliver my presentation on the topic using local climate zones to detect urban heat island in Indian cities, a case study of Kolkata metropolitan area, India. I have done my presentation under the supervision of Dr. Kasturi Mukherjee and Dr. Pratik Das. These are the topics which I'm going to discuss today. Land cover indicates the physical land type as forest or open water, whereas land use documents how people are using the land. A change in land use and land cover is the precondition of urbanization. By 2050, close to 7 billion people are projected to live in urban areas. Due to urban development, natural landscapes are affected. Water surface is shrunk. Agricultural land is switched to construction land to appear more and more impervious surface, change in the thermal property of soil. At present, the deterioration of urban thermal environment has become one of the most significant features of global climate change. It has increased the emission of atmospheric pollutants, causes the heat island effect, and lead to the land use change. An urban heat island occurs when a city experiences much warmer temperatures than nearby rural areas. After sunsets, the building form a canopy structure, preventing the heat loss to the upper atmosphere. Thus, the temperature remains elevated, and so the heat island effect persists during the night as well. Impact of urban heat island: general discomfort, respiratory problem, heat cramps, non-fatal heat strokes, and increase in energy consumption, etc. Classifying urban and rural environment is a challenge in understanding urban climate, especially urban heat island. Considering the fact urban heat island measured through land surface temperature, but measuring air temperature is as equal as important. So, Stewart and Oak developed local climate zone LCZ classification in 2012 to clarify these distinctions using 17 unique groups considering sky view factor, aspect ratio, building surface fraction, impervious surface fraction, height of roughness, elements, etc. These 17 classes is divided into two subclasses. One, build-up types, two, land cover types. Build-up types starting from LCZ 1 to 10, land cover classes starting from LCZ A to G, that is 7. This picture is showing World Urban Database and Access Portal tools. It is an open website where we can get LCZ classification of various metropolitan cities done by research scholars, and also download training samples for classify your city, and we can also upload our work in this portal. Coming to literature review, some of the paper I have reviewed for my work. The first paper I have reviewed, which discuss about land use, land cover changes and impact of urbanization. As for example, Miller and his co-author said that the special pattern of urban land use and land cover transformation is predominantly conversion of green patches into impervious surface. Oak and his co-author in 1973 said that the result of urbanization and industrialization of human civilization is considered as one of the major problems of this century. For LCZ classification, Ajit Das and his co-author have identified low compact rise building, which is predominant in Shantiniketan planning area. The overall accuracy of LCZ class of the year 2000 and 2018 is 82.07% and 85.71%. I have selected Kolkata metropolitan area as my study area, and this is the location map. Kolkata metropolitan area is the largest metropolitan accumulation in eastern India, extending over 1,851.41 square kilometer, comprises of 4 municipal corporations, 39 municipalities, and 1 cantonment and part of 24 samiti. The growth of building, road, industries changing in urban thermal condition as a climate heat zone. So it needed a prior attention to address the climate change. My objective of my research work is to delineate the local climate zones in Kolkata metropolitan area and to evaluate the dynamics of local climate zones between year 2011 and 2021. For the methodology, I have divided my methods into 2 parts. Firstly, I created training samples from Google Earth, and with the help of training samples and satellite data, I have run random forest classification in Saga GS. After the completion of classification, I have done accuracy assessment by generating 100 random points through Google Earth. And then the second part, I have calculated land surface temperature. For data, I have used 2 types of Landsat image. First, Landsat 8 for calculating Landsat surface temperature and LCZ classification of the year 2021, and Landsat 5 TM for LCZ classification of the year 2011. This map is showing land surface temperature of Kolkata metropolitan area having different municipalities. By this map, we can say that urban heat island is prevailing in KMC and spreading in its peripheral areas, and the difference between rural and urban temperature has become almost equal. So it is important to know the urban geometry so that we can study urban air temperature. For identification of LCZ, it is important to create training samples of the urban structure and land cover. So I have taken 15 training samples of each classes comprises of compact high-rise having dense mix of tall buildings to 10 stories, compact mid-rise consists of dense mixed buildings 3 to 9 stories, compact low-rise having 1 to 3 stories of dense mixed buildings, open high-rise having of open arrangement of tall buildings of 10 stories with some glass construction materials, open mid-rise having open arrangement of buildings 3 to 9 stories, open low rise, open arrangement of 1 to 3 stories, lightweight low rise having dense mixed single story buildings with no trees, large low rise having open arrangement of large low rise 1 to 3 stories, sparsely built sparse arrangement having small or medium sized building heavy industries. For land cover, there are 7 classes, that is dense trees, scattered trees, low plants, shrubs, bare rock or paved, bare rock or sand, and water. This map is showing CZ classification of KMA of 2021, where I got 16 classes of LCZ, where LCZ 2, 4, and 6 having maximum area, and in the case of land cover, LCZ D have, that is low plants covering maximum area. This map is showing LCZ classification of Kolkata metropolitan area of 2011, where I got 14 different classes, where LCZ 3 and 6 covering maximum area, and in land cover LCZ A and LCZ D cover the maximum area. I have done accuracy assessment of both year, where in 2021 I got 73.75 of overall accuracy, and kappa coefficient is 0.71, which is acceptable, and in the year of 2011 I got 80.30% of overall accuracy, and kappa coefficient is 0.76, which is also acceptable. This map is showing temporal change of LCZ classification from 2011 to 2021. Finally, as a result, I got maximum change in area of LCZ 6, which converted into LCZ 2 and LCZ 4 from 2011 to 2021. Growth of LCZ 1 and LCZ 2 has been seen over the past 10 years. In the case of LCZ land cover, maximum change in LCZ D, that is floor plans, converted into LCZ 1, 2, 6, and 5. I have shown my result through graphs. These are graphs. As for summary, I wanted to say that the rate of urbanization increasing rapidly over the decades. However, we can see growth of LCZ classes has increased over the last 10 years as been observed, which is leading to urban heat island and affecting the climate pattern of Kolkata metropolitan area. The city of joy is turning into the city of concrete. Limitation of my study due to pandemic, I couldn't visit field for survey. That is why I could not incorporate physical properties such as sky view factor, building height, etc. For the future study, I will try to incorporate physical properties for better result, and I'm planning to use LCZ map as an input in UMAP for SWES modeling, that is surface urban energy and water balance scheme modeling. These are the references which I used for my presentation. That's it for my presentation. Thank you.
Thank you, Devasmita, for your presentation. So our next presenter is Deblina Paul, presentation number 52. Dr. Bhadru, please share Deblina's presentation.
Good afternoon, everyone. I'm Deblina Paul, student of MSc Geography, Adamas University. Today, I'm going to present my work that is assessing the urban environmental quality, a case study of Kolkata metropolitan area, India. These are the following topics that I am going to discuss in today's presentation. So the background of the problem is that the process of making an area urban is known as urbanization. It is one of the major problems towards pollution which can be driven by urban heat island. The heat island is created by the consumption of energy in the urban areas that can change the local weather pattern. As the urbanization is related to industrialization, the smoke, chemical spills, and toxic gases from various industries contaminate the air and makes it unhealthy. As the high density populated area consume more energy, which leads to more contamination and pollution. The scale of pollution changed dramatically in the 20th century. It became more intensive with a growing number of pollutants discharged in the biosphere. Urbanization affects CO2 emission and heat budget. The graph here is showing the CO2 emission is increasing enormously. Here the first table is showing the top 5 cities having good air quality, and the second table is showing the top 5 cities having bad air quality. So coming to literature review, the study of David and his co-author observed that air pollution is widespread across the megacities and is often most severe in cities in developing countries. The study of Littman and his co-author observed that the urban disadvantaged are constantly subject to deterioration of environmental quality, human health, and quality of life. Coming to the study area, we have chosen Kolkata metropolitan area as a study area because it is one of the major urbanization node that is facing rapid and unplanned urban growth from the last decade. The area covers 4 municipal corporations along with 39 municipalities, 1 cantonment, and parts of 24 Panchayat Samiti. The objective of my study is to assess the environmental quality of Kolkata metropolitan area. Second is to compare the environmental quality among the densely populated cities of Kolkata metropolitan area. So coming to the methodology, firstly, Landsat 8 OLI image of 2018 summer have been used to calculate LST, NDBI and NDVI. Firstly, top of atmosphere radiance have been used to calculate LST, and then we get the output in Kelvin. We convert it into Celsius. Following the same process, LST is calculated with the surface radiance, then average of these two generated output is the final LST of the area of interest. On the other hand, the band reflectivity of red, near infrared and short wave infrared have been used to generate NDBI and NDVI. Parameters such as noise, PM2.5, PM10, NO2, SO2 have been collected from Central Pollution Board website. To analyze the rate of contribution of this parameter to environmental quality, experts scoring are taken for criteria weights. Then the consistency index and consistency ratio have been calculated. Finally, urban environmental quality index have been implemented to find out the result. The map here is showing the distribution of urban environmental quality parameter. We can clearly see that there is a positive relationship between NDBI, LST and pollutants, and there is a negative relationship between NDBI and NDVI. In this map, each parameters are classified into 5 classes, that is very low, low, moderate, good, and very good. The table shows the decision matrix that are taken from the experts. From the result, I get a consistency ratio of 6.7%, which is acceptable. This table is showing the ranking of the parameters influence based on their environmental quality. This is the formula to calculate urban environmental quality index. Here, the first map is showing urban environmental quality index, and the second map is categorized into 5 classes following natural breaks cluster analysis to obtain the environmentally poor zones. Here, the first map is showing the municipalities of KMA that are overlaid on the urban environmental quality index map. The next map is showing the environmental quality of top 5 top 10 mostly populated municipalities of KMA. Among the highest densely populated municipalities, none has a good environmental quality. From the graph, we clearly understand that Boranagar has the poor environmental quality index and Risha is at a better position than the rest of the municipalities. The result of my study shows that there is a positive relation between built-up and the other parameters such as temperature and pollutant, and negative relationship between build-up and vegetative cover. NDVI is moderate in the study area. Parameters such as SO2, NO2, PM2.5, PM10 are far higher than the permissible limit. The entire KMA is above the permissible limit of noise. Top 10 municipality of KMA show moderate to low environmental quality. Boranagar has the most poor environmental quality. A limitation of my study are that field survey could not be performed due to unavoidable situation. For better accuracy, field survey need to be performed with the help of noise meter and sampler. Future scope of my study is to implement this methodology over a time period of 20 years. A special focus will be given on pre and post lockdown period, incorporation of more parameters which are more important for urban environmental quality such as humidity and wind speed. These are my references. That's all about my PPT. Thank you.
Thank you, Devalina, for your nice presentation. And our next presenter is Rituparna Acharya, presentation number 7.
Hello everyone, I am Adamas Acharya. I will deliver my presentation on forest fire risk zone mapping of Mizoram using remote sensing and geographic information system. Forest fire, as we know, is a hazard affecting the environment as well as human health and inducing climate change indirectly or directly. So the northeastern zone of India has been affected by wildfires or forest fires. So as per the report of Forest Survey of India, Mizoram, the northeastern state, one of the 7 northeastern states, has been affected by more than 20,000 forest fire incidents. So thus, the main aim of this study is to determine the correlation between forest regions and different biophysical variables existing in the same region, such as topography, soil moisture, distance from road, and settlements. Thus, the study area of Mizoram has been subdivided into distinct risk zones. This is the objectives, is to divide the study area into distinct risk zones by incorporating multiple fire risk inputs to identify those risk zones and assess the impact of forest fire on the depleting vegetation throughout the years. So, as I've already said, the Mizoram is a northeastern state and is a smaller state compared to the other states of India. And it is covering only 20,000 square kilometers. And it have a latitudinal extent of 21 degree 56 minute north to 24 degree 32 minute north, and longitudinal extension of 90 degree 16 minute east to 90 degree 26 minute east. So the flow chart is showing the methodology of the study. So as I said about the 3 indices, the FRI stand for fire risk index, then HFI stand for hybrid fire index, and SFI stand for structural fire index. And to estimate these indices, certain parameters are required. So these parameters are listed in this chart. You can see V stand for vegetation moisture, S for slope, A for aspect, E for elevation, R is distance from road, E is visibility settlements. So these are the parameters used for the calculation of these indices. So these parameters are also generated from the geospatial datasets like the settlement area. For generating the vicinity settlement, settlement has been generated from the land use land cover map of Landsat data by using the indices of built up area index. Then the moisture has been estimated from the index of normalized differential moisture index. Then the aspect, slope, and elevation, these three has been retrieved by the SRTM DAME. So this DAME has been used to calculate these parameters for incorporating them into the file indices. Then the roadmap has also been retrieved from the satellite data to calculate mainly the proximity to the roads. So using all these parameters, these indices has been estimated. As you can see the formula there. So these are the maps of those input parameters. In elevation, you can see this 2169 meter high, then low is 66 meter, then slope. Maximum area is under moderate to steep slope because Mizoram area comes under the hill region. That's why the maximum area is under moderate to steep slope. Then the moisture content of environment in Mizoram is under high to moderate moisture level. Then other than this, the road map have also been estimated using the geospatial datasets. Then a cluster map using BUI, mean built up area index, has been estimated. These settlements. So these are the same maps which are reclassified for ranking them as per the risk. So as you can see, in case of elevation, the higher elevation indicate high risk for forest fire because at higher elevation there is chance of wind speed is high, being high. So the higher the wind speed, the fire will spread more quickly. Then in lower elevation, the wind speed is quite low. Then the forest fire has lower probability of spreading. Then the slope. The steeper will be the slope, the more the forest fire will spread. So in general slope, the forest fire will not spread in such pattern. Then in case of aspect, the eastern portion of the study area is mainly populated by the deciduous and arid vegetation, which absorb heat, and due to lack of moisture, that area is prone to fire incident because of the presence of dry vegetation. And rather than this, other areas, they don't, other aspects like north, west, and south, they don't comprise of that type of vegetation. So the probability of fire index is less. Then in case of moisture, it has a negative relation with fire. And the higher the moisture, lower will be the chance of forest fire. Then distance from road. So it's a road, it is part of the built up area by human settlements. So the closer will be the fire incident to the roads, the risk will be high. So if the fire incident is happening far away from the road, then the risk will be low. So the same thing is applied to the settlements. The closer will be the fire incident, more risk, and higher risk it will be. So these are the three indices which has been estimated, and their relative frequency curve has also been estimated. And these curves are indicating the range within which the fire risk will be high. So for FRI, the range between 147 to 250, the fire risk is high. Then for HFI, means hybrid fire index, 169 to 250, the range is indicating high fire risk. Then for SFI, 187 to 250 is indicating high risk of forest fires. So then this line graph is the probability distribution curve. So if we can observe the horizontal axis, So there 1 to 10 is indicating lower risk of forest fires. Then moderate risk is within 20 to 50. Then high risk of forest fire is from 60 to 100. So this probability distribution curve has been estimated on the basis of the indices. So the area has also been calculated of those indices. And among these, the SFI has graded 6 square kilometer as high risk zones. Other than this, the total high risk zone calculated by all these three indices, total high risk zone is 58.4 and the low risk is 42.3. Then for HFI and FRI constituted 5.3 and 6.6 7 kilometer as highly risk zone susceptible to fire, highly fire risk zones. So these are the bivariate plots where the vertical axis comprising of those fire indices and the horizontal axis is the data of hotspot collected from Moody's. So it can be inferred that the FRI is showing a value of 0.89. So that is accuracy high. But other than FRI, the HFI has moderate level accuracy and SFI has lower level of accuracy. So this is the validation map where it contains the hotspots collected from the Moody's datasets. So the main indices are distinct, so that's why the parameters also vary, as well as the various formulas also vary. So from this, it can be inferred that FRI provide more accurate outcomes than SFI and HFI for the identification, because as you can see in the previous graph, the FRI has high accuracy, so it is more accurate. And it can be seen that the hotspot areas are mainly near the cultivated land, roads, and settlements. So these indicate that the human activities are causing a growing number of wildfires, affecting the environmental equilibrium and as well as inducing the biodiversity depletion. So these are the findings. So and now I am my slides here and in my presentations here. Thank you.
Thank you, Ritivarno, for the nice presentation. So in the last presentation of this technical session, presenters are Rubesh Mollik, Samudra Roy, Kesang Bhutia, and Meghanandi. And dear participants, you can post your question to the presenters of this technical session in the chat box.
Good afternoon, fellow presenters and scholars. The topic of our research is spatio-temporal analysis of environmental criticality, planned versus unplanned urbanization, presented by Rubesh Malik, Samudra Roy, Kesang Bhutia, Meghanandi, undergraduate students, BSc Geography Honours.
Urbanization has long been associated with humans' development and progress, but recent studies have shown that urban setting can also lead to significant inequalities and health problems. Urbanization is the outcome of migration of people from rural to urban region. With this, not only urban boundaries expand, but creation of new urban centers also contributes to urbanization. An important factor, land surface temperature or LST is how hot the surface of the earth is to touch. In satellites' points of view, surface is basically the ground that it sees through the atmosphere. The temperature difference between urban and rural setting is known as urban heat island. The large amount of heat generated from the urban structures, they consume and re-radiate solar radiations, and from the atmosphere, anthropogenic heat source are the main cause of UHI. The progress of urbanization produces radical changes in the surface and atmospheric properties of a region. All of these changes induce the modification in the climate balance, creating a new climate called urban climate. Background of the problems. Land is important as it not only provides shelter but also support economic activities. Land has been modified since ancient time for various reasons, including searching for food, shelter, and etc. On one hand, urbanization brings us material comfort, basic amenities, improving the basic standard of living. But on the other hand, it brings about several problems such as climate change, global warming, dumping of toxic industrial waste in water bodies, air pollution, damage of ecosystem, etc. Literature review. Land cover is defined as the collection of biotic and abiotic components which cover the surface of Earth, while the land use is described as how the land cover is shaped by the human being. It was recognized that land cover changes modifies surface albedo and surface atmosphere energy exchange, which have an impact on regional climate. The land cover maps prepared from remotely sensed satellite data used to determine the dynamics of urban expansion, patterns, and spatial configurations. The land surface temperature is the radiative skin temperature of the land surface as measured in the direction of remote sensor. It is estimated from top of atmospheric brightness temperature for the infrared spectral channels of a constellation of geostationary satellites. The importance of land surface temperature retrieved from high to medium spatial resolution remote sensing data for many environmental studies. Practically, the application related to water resources management over agriculture sites was a key factor for the final decision of including a thermal infrared or TIR. The current trend of urban growth has the most imperative impact on the thermal environment in which the urban region become hotter than their rural surroundings, constructing an island of higher temperature. The vegetation loss and increase of impervious surface subsequent of urban growth result in the absorption of retention of heat which is re-emitted after the sunset, creating a steep temperature gradient between urban and rural areas.
In the urban context, urban growth is bringing about drastic impact on thermal environment of a region. Better said, an urban region is becoming hotter than their rural counterpart. This is further aggravated by loss of green cover, vegetation, increase of impervious surfaces. This leads to an increase in heat absorption and retention, further creating a steep temperature gradient between urban and rural areas. The UHI phenomena is defined as when urban areas have higher air and land surface temperature compared to the rural areas. The surface urban heat island is used to refer to the difference that is higher surface temperature of urban surfaces compared to rural ones. SUHI is measured by estimating LST extracted from our remote sensing, which can be performed at regional and at a global level. The basis of our research is two urban areas of West Bengal, India. One is Barasat of the district of North 24 Parganas with a population of 1.06 lakhs, and Kalyani of Nadia district with a population of 2,78,235. So this is a map. On the bottom left corner, we can see the district of Kalyani, and on the bottom right, we can see the district of Barasat. So on this slide, we can see visually a visual side-by-side comparison of the urban growth of Barasat from a time period of 2005 to 2020. Similar for Kalyani, a side-by-side comparison of the urban growth between the year 2005 and 2020 is clearly visible. So the objective of our research is analyzing the urban dynamicity of urbanization and consequent impacts of development in cities of India, and comparing the urban environment between a planned and an unplanned one. So for the details of data used, this is a table showcasing the data we have utilized in our research. For the years 2005, 2007, 2010, we used data of Landsat 5 with thematic mapper sensor. For the years from 2014 to 2020, we used data from Landsat 8 with sensors, operational land imager, and thermal infrared sensor. The pattern row is 138 and 044. With spectral band 7 was used for 2005, 2007, and 2010. Spectral band 11 was used for the years 2014 to 2020, and the radiometric resolution 8 for the years 2005, 2007 to 2010, and 16 for the years 2014 to 2020.
Methodology has been divided into 4 major sections: calculation of land surface temperature, normalized difference vegetation index, and normalized difference built up index, and ECI. All of these works have been done in ArcGIS. Here the satellite data or the thematic mapper and the operational land imager have been used. For the land surface temperature, we use thermal infrared sensors 1 and 2 and converted the digital numbers into top of atmospheric radiance. After getting the top of atmospheric radiance value, we calculated brightness, temperature, band specific thermal conversion constant, and get our result temperature value in Kelvin. Now we convert this temperature into Celsius and we will average them to get the required land surface temperature. For normalized difference built up index, we calculated for Landsat 8 by using, we calculated the normalized NDVI by using short wave infrared and near infrared maps. For Landsat 5, we use short wave infrared and near infrared bands. For NDVI, normalized difference vegetation index, we use the infrared and near infrared and red bands, that is the band 5 and 4 for Landsat 8 and band 4 and 3 for Landsat 5. For calculating ECI or environmental criticality index, we first calculate the built up area index by using a difference of NDBI and NDVI. The area will stand, the waste area, wake area will stand out if the reflectance of vegetation is reduced. Then we calculated our ECI using the built up area and land surface temperature data.
So here we can see the land surface temperature of Kalyani and Barasat. Here, the 10 analysis, we can see that that the temperature of both unplanned and planned city has risen throughout our time period. The Mann-Kendall trend test was applied on the average data of Kalyani and Barasat, and the resultant p-value was greater than the determining of p-value, as the computed p-value is greater than the significance of level alpha, which is 0.05. We cannot reject the null hypothesis and can conclude that there is no trend of rise or fall in our data. So this is the LS, land surface temperature of Kalyani and Barasat given in a line graph. So there is not much any difference between the two of them. So from the mean temperatures of Kalyani and Barasat in 10 years, we can see that the yearly variations of the temperatures is very close to that of the planned city. We can interpret that in the beginning, the land surface temperature of both the regions was gradually increasing. So, and at the end of 2020, so we can interpret that the land surface has increased in the last 15 years that we have in our research. This is the, we have calculated the built-up index of Kalyani of the last 15 years, along with the built-up index of Barasat. And this is the NDVI, means normalized difference vegetation of Kalyani as well as Barasat of the last 15 years. So in the spatiothermal analysis, it shows that in summer, the trending average of built-up index is increasing at 0.084. That is in Barasat, and in Kalyani it's 0.12. So, and the results is reducing of that is denoted by green vegetation. In the year of 2015 at Kalyani, we can see both NDVI and NDVI and NDVI simultaneously. It can be happened due to high amount of vegetation land as well as high amount of built-up area. So from in 2015, in 2005 to 20, the highest built-up index we can see in 2010 for Barasat, for both Barasat and Kalyani, which is 0.08 and 0.12 respectively. So for both the cities, there is a huge difference between 2005 and 2020, from which we can say that during this period, the average built-up area is increased. In this picture, we can see that the environmental criticality index is calculated for both Kalyani and Barasat. So the ECI is mainly used to identify sensitive areas that results in sharp thermal slope between city center and the suburbs due to existence of cool thermal island in cool thermal island.
Limitations of the study. We had several limitations in our research. First being that the USGS data is inadequate. It was used with unequal gaps as many layers had cloud covers which could not be removed and other features which made it hard to study. Ward level detailed data of required variables are not available. Data is incomplete. Only the effect of summer months has been analyzed. Sudden change of global events like the coronavirus and cyclones like Amphan did hinder the previous trends of data being studied. Analyzing the total data, we found out that the difference of LST, ECI, and buildup and vegetation cover was not so varied among themselves. So therefore, we can conclude that the planned city has less impact as compared to the unplanned city. Suggestion: utilization of cool roof coatings and roofing materials will somehow decrease the warmth of the city. This will be most beneficial for crowded areas. Another suggestion would be of little spread out urban expansions that could be surrounded by planted trees, either on roadsides or dividing areas, can contribute to somehow lowering the urban heat island effect. Urban expansion should occur in lieu of a balance with the environment and availability of the required facilities. This can make us a healthy city. Future scope. Our future scope is to understand in an in-depth analysis, correlation can be performed comparing the cities. This can be further expanded or modified by taking data from every year. That would give us a more appropriate analysis. Using sky view factor and heat analysis, the effect of urban heat island can also be analyzed. As our study was hindered this time due to the pandemic and due to natural climatic occurrences, we do plan in our future to do a valid field study to bring solidity of our study. These are the references that we utilized for our study. We come to the end of our presentation and our research. Thank you very much.
Good afternoon.
Thank you, Rubesh, Somudro, Kesang, and Megha for your presentation. And as we have a very limited time, and we do not have significant question, large number of questions. So we are going to conclude this session with the summary. And first of all, I wish to express my sincere thanks to Professor Gerald Mild for his very good technical presentation in this session. And in this session, we have 5 presentations from the presenters. Mostly of them are the students, and all of them have worked completely on remote sensing and GIS. That means they have used geospatial technology, and the work mostly comprise, and 4 work comprise on urban environment and 1 work on forest fire risk. So first, the presentation number 27, which is done by Trishita Ghosal, Deblina Paul, and their co-authors. They have used Google Earth Engine to process MODIS data for estimating the relation between urban growth and land surface temperature. The presentation number 51, Devospita Bhomik and the co-authors tried to derive local climate zones in the Kolkata metropolitan area. Presentation number 52, Deblina Paul and co-authors tried to calculate urban environmental quality of Kolkata metropolitan area. And presentation number 7, Rituparna Acharya and the co-authors tried to identify forest fire risk zone in Mizoram. And finally, the presentation number 50, Rubesh Maulik, Somudra Roy, Kesang Bhutia, Megha Nandi, and the co-authors tried to identify the spatio-temporal pattern of environmental criticality and land surface temperature in a planned and unplanned urban area, that is for Barasat and Kalyani. And all of these 5 works are very good. I must congratulate to all of the presenters. They did very good works. And as all of them are mostly students. I must express my sincere thanks to them, and I hope all of them would be very good researcher. Most of them would be good future geographer. Thank you all.
Thank you,
Now,
thank you, Professor Mill. So, sir, can you please give us the marks using that Google link? Sir, are you saying something? You are, I think, on mute. Yeah.
Sorry, I was just listening and taking notes. I didn't fill out a form.
Okay. So is this possible for you to fill up the form, or you can send me the note if you want to?
Do you need that immediately, or can I give it to you later on today?
Sir,
no,
not immediately, sir, but today only we are going to disclose the best papers at the end of today's session.
Okay, well then I'm going to go away then and do it because I have to travel. So
okay, no problem.
Send it to you in about an hour.
Okay, sure, sir. Thank you. Thanks a lot.
Okay.
Thank you for listening. Thank you.
Thank you.
Okay. Dear participants, we are in the last technical session of the 2 days international conference we were having. And in this session, we have Professor Sugato Hajra from Jadavpur University as the keynote speaker, followed by 6 presentations. And to chair this session, I would like to request Dr. Rajiv Sharkar from Adamas University to come to the conference, and Dr. Tuhin Bhadro as co-chairperson to take over this session.
Thank you, madam.
Thank you, madam.
Humble introduction. Can you hear me?
Yes.
Audible?
Yeah.
Yeah. Now I like to request Dr. Tuhin Bhadro to,
Yes, sir, we can hear you.
To introduce our keynote speaker, Professor Sugato Hajra from the Oceanographic Studies Department, Jadavpur University.
Thank you, Dr. Rajiv Sharkar, for giving me the opportunity. And now I will give a brief introduction of Professor Sugato Hajra. Dr. Sugato Hajra, Professor, School of Oceanographic Study, Jadavpur University. Can you hear me? Excuse me. Hello. Has been involved with researches on oceanic resource and coastal management, climate change and populous deltas, petroleum potential of cold thrust belt, tsunamis, coastal disaster, marine fishing zone prediction and validation, carbon flux estimation, and many others. A member of 16th Indian Antarctic Expedition, he has also done pioneering work on vulnerability and impact of climate change in Indian Sundarban. He established the full-scale remote sensing and GIS laboratory at the School of Oceanographic Studies, Jadavpur University in 2003. With over 30 years of teaching and research experience, Professor Hajra has contributed more than 160 scientific research papers and book chapters in national and international journals, and associated with more than 15 national international projects as a PI and co-PI. With this short introduction, I'd like to invite Professor Hajra to start his presentation.
Thank you, Tuhin. Can you see that presentation, the title page?
No, sir.
You cannot. Oh my God.
You have to share your screen or share the
shared. Okay. Screen sharing failed to start. Okay, let me see. Can you see now?
No, sir.
No.
So you get an option, share screen option.
Yes, but it is not sharing. Let me just check. Let me stop share. What should have been tested earlier. Let me just go to this thing. Okay. The connection is going. Is it?
No, it is not visible.
Can you see now?
No, sir.
No.
No.
I think then I have to talk only.
You can also share your presentation. I can share.
Sharing has failed to start. It is telling. Shall I just join again and see?
Yes, you can rejoin and share your presentation.
Yeah.
Join again and check out if it is working at this point. Else you share it with Puneet. You will be sharing the screen and you will just deliver your lecture.
Okay, I've come back, but I'm sharing the screen now. Why it is going back again? It is screen sharing is always, it is telling that it's failed.
So you can also share the screen one, or you can share separately the presentation. You'll get different option under this screen share. After clicking screen share, you can select screen one or other windows. From other windows, you can select your presentation.
No, right. It was happening for all other last times. Okay, let me see. I think you'll be able to see now.
Sir,
Is it okay?
will you please press S, Alt plus S or Alt S?
You are not able to see now also.
No, sir.
Sir, it is not visible from our end.
No, it is failing. Okay.
So better, sir, you send it to Tuhin in the email.
So you can also send your presentation through mail, and I can share.
Yeah, I think I'll do that. Just hold on. Yes, I've sent it. Okay. Please check whether you have received it.
I have not received it, just waiting for. Have you sent it to my Gmail or this Adamas University?
I've sent to both you and Kosturi, but in the address of Twin Bhadra, I think Gmail. Oh, adding attachment, it is still
Okay.
not gone. Let me also send a PDF.
Yes, PDF will take.
Why it will not come, I don't know. I think it is because of the network
Yes,
problem.
sir, maybe.
Might be this taking.
And maybe the size of your presentation is large, therefore it's
No,
not.
it is not very large. It is only 13 slides, maybe. Okay, now I think you can have both. No, it is still not gone. None of this are going. Okay, let me try again.
So we are facing some technical issue. I'll request all the participants to wait for another 5 minutes, and we'll start short.
It is always showing an error code of 105035. That means
So can you send me the PDF file only separately, not with this PPT version?
no, that also I have sent you.
Okay.
But you are yet to receive it. Is it? It seems like that.
Yes, sir. I have not received it yet.
Oh, the sent is also not
Yes,
showing.
I have just received.
Just received it?
Email. Yes, sir.
Yes, the PDF you must have got. No?
Yes, the PDF one.
Okay, you just show that. Can you start?
Yes, 1 minute.
I think this damages all the spirits that one can have in this kind of session. And I'm sorry for that. I think it is low bandwidth or something like that. It was not able to transmit the presentation. And this is a major problem of our technology dependent learning and I mean assessment of art also. That we cannot do without it, but we have to suffer the technical problem. So Twin, are you ready with that PDF?
No, sir. I got a notification in my phone, but I'm unable to see it in my laptop.
Oh, you have got a notification.
Maybe within few seconds I can.
Okay. Or Kosturi, have you received in your phone? Mail?
Yes, I have received it now.
You have
Just
received it now.
I'm downloading the presentation. Then I'll start.
Should have been done earlier.
So is
Okay,
it
great. Yeah, fine. And I'm starting without much delay about it. Actually, all of you have seen in the last year this image that it came in the newspaper also. That was a model done by Climate Central, USA, showing that by 2050, due to repeated flooding, these red areas, which includes our city as well as Sundarban, would be flooded. It includes major part of the Bangladesh as well as India. Uh, can you hear me? Okay,
Yes, sir, we can hear you.
great. So if you go to the next page, but we are not exactly alone. Twin, you may go to the next page. Yeah. The same year, the India Today carried out this total coverage, which was showing that the extensive area of Gujarat, Mumbai, Kerala, or Chennai will also be flooded by 2050, and the flood will be coming from the seaside, not from the flood may not be the permanent rise of sea level, but it may be a temporary rise of sea level, which may go inside the land. So this is not a very good situation for the city. And when I was in Bangalore, it was in 2019, I think. Yes, end 2019. And Climate Central is a very well-known agency who has done a reassessment of the SRTM, that is a subtle radar topographic mission data, that actually overestimate our topographic measurements, particularly in the cities and in the forest. It calculates also the height of the building as well as height of the trees. So you always get a higher results from SRTM about any altitude. So if you want to measure the altitude of a place from satellite. But so what they did, they actually by a modeling, they eliminated the building heights and eliminated the tree heights to get the real topographic height, and they launched another DEM, which is a very sophisticated DEM, which is called coastal DEM. It is much more advanced because it is derived from SRTM, but much more advanced than the SRTM. So if SRTM and these coastal DEM data shows this kind of inundation, then we are faced with two kinds of uncertainties. One is either our topography is not correct, or the topography assessment is not correct, or our sea level rise measurements are not proper. So we tried to delve in much details about the variability of sea level rises along our coastal areas. So the report carried that in India, the Diamond Harbor is very close to us, very close to Adamas actually, much more close, or it is closer to my house. That is showing the highest rate of sea level rise, that is a 5.2 millimeter per year, nearly double than the global average. It has been placed by the Ministry of Earth Science, Government of India in the Parliament in 2019, January. Simultaneously, you can see that the Paradeep is showing a much lower rate of sea level rise to 1 millimeter per year, or Holdia is showing around 3 millimeter per year, whereas Mumbai is showing the rate of rise is 0.7 millimeter per year. Kandla is, on the other hand, in Gujarat, is showing a higher rate of sea level rise. So what we generally think that the sea level is a global phenomena, you can observe with these, simple data that the sea level, even the rate of rise, are not consistent or constant along the different coastal sector. And what we are observing here is a relative sea level rise, or what is measured from the land-based tide gauge data. Next, please. Yeah, so the tide gauge data, as you have seen, that it can vary spatially also. Like in Kolkata and close to Kolkata, we have four observation stations. That is one Diamond Harbor, one is Shagor, another is Garden Reach, another is Holdia, and Gangra. Gangra is the East Medipur. Rather five, but if you see that, if you just go down, can you go down a little? Yes, yes. So in this plot, which was done by one of my students, Ananya, in her MPhil thesis, that the sea level rise is not similar in all the close nearby area. So the rate of rise varies with the place where in the estuary the port is situated. Like if it is in the very inside the estuary, the rate of rise at Garden Reach can be corrected to be shown to be 7.12 millimeter per year from a data of 1932 to 2014. So this is the longest record of data showing the highest rate of sea level rise in Calcutta, actually, Garden Reach. It is actually in the top of the estuary, whereas in Diamond Harbor, it is 4.42 or 5 millimeter per year in this range. Or Holdia, it is less, it is open coast. Gangra, it is further open coast in East Medinipur, 1.51. Or Shagor, it is just at the mouth of the estuary. It is also close to 4.5 to 5 millimeter per year. So the tide gauge results are showing different altitudes, because these are also affected by land subsidence. So here comes the second uncertainty. Other than the rate of sea level rise, which varies spatially, we can have a temporal variation. You can go to the next slide, please, Twin. Yeah, so if we analyze the Diamond Harbor data much more closer way, because it is the most dependable tide gauge in our station, the longest record. The ministry declared in 2019 in Lok Sabha that it is in India we have highest rate of sea level rise in Kolkata, but I don't know whether the planners, the urban planners of Kolkata, or the coastal zone planners, or whoever are fighting in the elections now, are concerned about the highest rate of sea level rise in the delta area. But the very interestingly, if you split the record, you can see that while a mathematical average of 1948 to 2020 will give you around 3.6 millimeter per year, between 2006 to 14, you can have a 12 millimeter per year sea level rise. So that gives us a point of further uncertainty at which period of tidal cycle we are measuring the sea level, because there are astronomical tidal cycles, there are El Nino phenomena. So the relative sea level rise can be higher at a particular point, much, much higher than your national average. So in the nation, you may not be ready to take up any particular action about how to adapt or how to mitigate the sea level rise or the impact of sea level rise. However, in the 6 to 14 period, your largest part of Sundarban area might have been flooded, might have been inundated due to very high rate of sea level rise, which is 12 millimeter per year. So go to the next slide, please. So this is the problem of land-based measurement and the mean sea level that we are taking. Because last year also somebody called me that, do you know that Everest has grown up by some feet or 8 feet or so? I tell them, oh, is it? It was growing, I know, but it has grown so fast to 8 meter. I didn't know that. I have not observed it because it is not a part of the oceanic measurement anymore. Mm. So then I realized that the mean sea level that we considered was actually surveyed from only 9 tide gauge stations, which were showing this kind of data in 1909. So that is our mean sea level, depending upon which you decide that Adamas University is 7 meter above the mean sea level, or Calcutta is like that, or Diamond Harbour is like that, or Mumbai is like this. So this, at one hand, the sea level is changing, and on the other hand, the land level is either subsiding or getting uplifted, like Himalaya. As in Chennai, you have seen that the rate of sea level rise is 0.73 millimeter per year because the land itself is rising there, whereas that in the delta of Sundarban, the land itself is subsiding and is showing a very high rate of sea level rise of more than 5 millimeter per year. So are we now satisfied with our data, or do we feel that we should do something about our sea level measurement, our land subsidence measurement? Because we have to develop a coastal megacity, we have to develop smart cities. So it is not only measuring population and measuring urban settlement, but anticipating the hazards that the coastal megacities all over the world are facing. Bangkok is subsiding at a very high rate. Jakarta, the capital, is being shifted because of high rate of subsidence. So what is about our concept about subsidence? If we go to the next slide, please. These surveys will not be sufficient. Yes. So what we did, we used 2 different types of technique. One is the differential satellite altimetry to measure something around the subsidence level around Kolkata, and we tried to extend that observation through the GRACE satellite observation in the entire delta part. This was also done by Ananya in her MPhil thesis, and now Tona is taking up with the help of JAXA. We got the Aleph pulsar data that will be analyzing the delta X subsidence. But you can see this subsidence itself in different part of Kolkata, like Koshba, Beleghata, Maniktola. These are exceeding 5 to 6 millimeter per year as per the satellite measurement. These are provisional measurement. It needs to be tallied. Whereas in the Santoshpur Gorfa side, it is showing the little lesser subsidence. So this same picture is coming depending upon the water withdrawal from the subsurface. Probably GRACE, which measures the gravity data basically, is showing a gravity depletion here and increase in the southern part. So next, and if we extend it in the delta area also, we will see that the subsidence rate of around 1.4 millimeter or 1.7 millimeter per year in the northern part of Shagor Island, whereas in the southern part of the Shagor Island, it might be a little less. But the tide gauge station of Shagor is situated in the southwestern corner of the island. So you can understand that being an oceanographer, what we should do about sea level rise. Our sea level rise varies spatially as well as temporally. Our sea level rise varies dependent upon the differential subsidence of land. Then how can we estimate a perfect sea level? Next. Because there are extreme sea level conditions like we have seen in the case of Amphan cyclone. There was a storm surge. Storm surge has temporal rise of sea because of the low barometric pressure and the wind thrust. So INCO has estimated that this part of Sundarban is a big habitational area. will be flooded, and the flooding will be around 1 to 2 meters above the ground level. So there it lies again, two types of uncertainties are there. One, what is your digital elevation model? Which model have you followed? Or what is the level of the sea from which reference point you are measuring? Because in 100 years, at least 1 meter rise of sea might have occurred around the sea, coast of India. Next. Then if you compare that, our one of our students, Saurabh, has compared it with the inundation map derived from the SAR image, and he could differentiate between the river water inundation, that is a saltwater inundation, and the rainwater inundation, which is not connected with the any kind of creeks or other things. So we could estimate that though the areas were flooded, but the amount of flooding is not as predicted. So there are divergences now, because if we have to plan accordingly, how much sea level will consider 12 millimeter per year rise, or 4 millimeter per year rise, or 1 millimeter per year rise, or what is the rate of land subsidence we will consider while constructing this kind of model. Next. So we tried, it is one of our published paper in Taylor and Francis in the spatial geoscience. You can go to the little down. So between 1990 with one of my students, Rojit Kaur, we did a compound assessment from satellite altimeter data of 1993 to 2010 with the gravity data from GRACE, and also the floating Argo satellite data, because Argo floating data, because that will give us a temperature and salinity data, and can help us to compute the steric level. Uh, so it has shown that the black one is the satellite altimetry driven sea level rise data, which is showing the total is showing 6.26 plus minus 129 millimeter per year, which is in conformity with the local sea level rise of, say, Diamond Harbour 4.36 plus minus 1.45 meter, which we could observe, and major part, as shown by the Argo float data, is also contributed by the thermal expansion of seawater, rather than GRACE is not suggesting any extra water mass due to ice melting coming from the uh, Greenland or Antarctic ice melting. So it is mostly thermal expansion and probably other components which are influencing the high rate of sea level rise as observed from satellite altimetry data, which should not be dependent upon the tide stations, but or the land subsidence. But go to the next, please. But here we are landed with the problem of which digital elevation model or which geode are to be selected, because Saurabh has again done a coastal DEM 3D in my insistence. It is a magnification of 200 times is there, so that you can see the height of this Jammu, this Shagor and Monsuni and other area, that part. But Terrasar, which is a German altimetry mission, is showing a German, you can say DEM. It is showing pretty high values, particularly in the interface of the land and the sea. Whereas the coastal DEM, because of its technology, procedures, it has flattened those areas. So go to the next, please. So which of the DEM to be selected when we are planning? So this is the comparison that we could do, that if we are to measure the height from the satellite altimetry, which and the geode needs to be selected appropriately, the Terrasar or the Tandem X, it has got a very good vertical resolution of 10 meter, much better than the SRTM, which is 16 meter. Uh, but we have a survey data of Moshuni Island, that is the red line below in this thing, which is actually closely corresponding to the coastal DM 90 with a resolution of 3 arcsecond and vertical resolution of less than 5.16 meters. This is done by the Climate Central, the improvement upon SRTM in 2016. So in this present situation, we do not have a very certain kind of MSL data. We do not have a close correspondence between the different digital elevation model that is floating around. Mostly our students use SRTM. Very few people so far have been using coastal DM. And the coastal DM itself has shown that exaggerated view of the flooding of Kolkata to Nadia, even in the case of sea level rise. So we are really, I mean, at a serious juncture of our technical as well as physical limitations of measurement of sea level and measurement of land subsidence. And unfortunately, our planners and policymakers, people who are fighting in elections, people who are voting in elections, people in the academia, people in the business, nobody have any serious attention towards the fact that whether is our city is under threat. So I think with this, I can show that what may happen next. If you can go to in. Yes. So this is the model that we are doing using coastal DEM. So if this total delta area is subsiding at a rate of 2.5 millimeter per year, half of the observation that we have taken at Calcutta, then by 2050 to 2100, 50% of Sundarban area will be gone. With the present rate of SROCC RCP 4.5 scenario, that is 1 meter sea level rise by 2100, or 0.7 to 0.7 meter rise by 2100. But if the subsidence rate, why it is subsidence is important in planning or policy making, because if we increase the rate of subsidence to 5 millimeter per year, which has been now observed in Calcutta and has been reported by Geological Survey of India also, then you don't see Sundarban in 2100. This was a SLAM or sea level affecting coastal marsh modeling, which we are doing at the present ongoing project under UKIRI DBT program, where Saurabh is participating. And so you can understand the seriousness, because we may not lose our homeland, but the tigers will lose. So many ecologists and tiger lovers and are they familiar with the situation that what will happen to the tigers? Will they be also migrant and coming to the Kolkata city? So I think I should conclude with this uncertainty and our consistent effort of the academia to solve the problem, to improve our technology. In Chagor Island, if you go, you will find that they are measuring the tide with a bamboo stick. And we have satellites in our orbit which can measure, and we have acoustic tide gauges which can be installed along our coast, also in Gangra port, also in Diamond Harbour, also in Holdia, also in East Medinipur, but we are not doing it because we are not sensitized enough that this is a threat which is coming from the sea, and because of our limitation of technology and lack of imaginative mind, probably we will be heading towards a definite disaster, though slowly. So next, please. So this is the kind of difference that can be seen in the Avisio MSL, EGM 96 MSL, and our sea level measured from the tide gauge data in 1909. So we can ascertain from our experience that we are close to the truth if we are using coastal DEM, but we are yet to ascertain why where coastal DM is actually did some problem so that our entire area is getting flooded up to Nodia by the model that they have shown in the published in the Times of India. And this is a debate also going on in the nature geoscience. You may see that how to calibrate all these digital elevation model and come up with a much more realistic data. And that is the reason the Aviso platform has been created. You can have a tide gauge corrected data of the digital elevation model, but with that also you may find difference in your measurement for garden reach or big garden, or say in that case Shagor Island. So with this, I think I will conclude here, and you go to the next slide, please, if there is any. Uh,
This was the last slide.
so I think I'll leave it here, open for the discussion and open for further action. And I hope that the young minds that have been assembled here, they will take it up further and can actually raise to the occasion and save our cities and cities like this in other parts of the world with much more accurate geodetic measurements coupled with field observations. Thank you very much. And I'm sorry for the delay and the technological problem. Thank you.
Thank you, sir, for this informative presentation. And I hope all the participants have learned a lot about these new methods of sea level rise measurement, or this coastal inundation mapping. So now I'll ask the participants to raise questions. If anyone of you have any question, you can ask directly to Professor Hajra, or you can also type your question in the chat box. Yes, you can write the question to chat
So
box.
that you can proceed. Meanwhile, yes, I can answer. Because you have to find for the lost time.
Okay, so we can now move to our next technical session, and I will request Professor Hajra to mark the participants. I shared a Google form link.
I have received it.
Yes. So I'll ask Dr. Rajiv Shorkar to read the name of our to read the paper name of our first presentation, and I will share the video.
Sorry to interrupt. My warm regards to all respected delegates. I would like to mention that the name of the topic has been edited a bit. The pre-recorded presentation and the abstract are already having the edited name.
Okay, can you just read the edited title of your paper here, and
Yes,
then I'll
yes.
start the video.
Okay. Determination of the change in health of vegetation using remote sensing techniques, green chlorophyll index, NDVI and RVI for Bankura district of West Bengal.
Thank you very much.
Thank you, Mr. Shorkar. So now our last technical session is going to start. Ornisha Shorkar.
Yes, I'm sharing her video. Just a minute.
We are going to have the presentation of Ornisha Shorkar on vegetation health mapping using remote sensing techniques on different forests of Bankura districts.
Okay, and she changed the title of his abstract, and this is her new title. So I'm starting the video now. Okay.
Hello. Today I, Priyadashi Bhattacharya, will present you on the topic of determination of the change in health of vegetation using remote sensing techniques for Bankura district of West Bengal, India. So we will look into the remote sensing indices after the completion of this introduction portion. Chlorophyll is perhaps the most important naturally occurring pigment. It is found in plants and some microorganisms such as cyanobacteria. The porphyrin ring present play an important role in the conversion of solar energy to chemical energy through a process known as photosynthesis. The term chlorophyll was coined in 1818 by French pharmacist. The different forms of chlorophyll are chlorophyll A, chlorophyll B, chlorophyll C1, chlorophyll C2, chlorophyll D, and chlorophyll F. But in this study, we'll only deal with the procedure of extraction of chlorophyll through spectrophotometer. For this, we will be requiring only the values of chlorophyll A and chlorophyll B. Chlorophyll A and chlorophyll B are the two major types of chlorophyll found in plants and green algae for photosynthesis. Chlorophyll A is the principal pigment involved in photosynthesis, whereas chlorophyll B is the accessory pigment. Finding of the chlorophyll concentration through spectrophotometry requires ammonium hydroxide solution and aqueous acetone solution. Both are mixed in the ratio of 1:9. Chlorophyll content in spectrophotometry is measured wavelengths between that of 645 nanometer and 663 nanometer. Thereafter, the calculation for the chlorophyll concentration is computed on the acquired readings of the spectrophotometer. The total chlorophyll concentration is calculated with the following formula. Chlorophyll is equal to that of the summation of chlorophyll A and chlorophyll B. The unit that is being used for the calculation is that of milligram per milliliter.
Till now, we have seen the plant physiological estimations for the extraction of chlorophyll. Now we will be looking at the remote sensing techniques through which chlorophyll concentration can be estimated. I, Anvesha Sarkar, would like to describe the further slides. We have taken the Bankura district for this purpose. The data of 1990 and 2020 has been taken. 1990 data is Landsat 5, whereas 2020 data is of Landsat 8. Here we can see the map of Bankura, and significant portions of dense vegetation can be seen in the northern and northeastern forests of Bankura. Portion of Panchit forest can be seen in the eastern parts of Bankura, and southern forests are present in the southern and southwestern portions of Bankura. Various vegetation indices have been carried out through remote sensing techniques. QGIS, Geomatica, and Adamas Imagine have been used. Green chlorophyll index, normalized difference vegetation index, and ratio vegetation index have been estimated. We can see that the places which are having higher values of GCI are the ones which also record high values of NDVI and RVI. Apart from that, a difference can be cited in the two distinctive years, 1990 and 2020. In the year 2020, there's a sharp decline in all the vegetation index. Normalized difference built up index have also been estimated, so that we can see that the places which are having high built up index are the ones which record low vegetation index. Let us move on to the next slides. The green chlorophyll index measures the chlorophyll concentration in plants. It basically indicates towards the plant's health. In 1990, the GCI has been recorded pretty much high. The highest value is 0.92, and we know if the values are approaching towards 0 or negative values are there, therefore it means that there are water bodies or bare soil. GCI value is basically calculated by NIR band divided by green band minus 1. On to the GCI in 2020, we can see that the frequency of pixel values have reduced very much. And next, when we are comparing the two values of GCI in 1990 and 2020, we can see that the pixel values of 1990 are pointing to a much greater extent as compared to 2020. The highest value in 1990 has been registered as 0.92, whereas that of in 2020 it is just 0.62. We can see a striking deterioration in the plant's health. Normalized difference vegetation index indicates towards the density of vegetation or whether vegetation is present on a piece of land or not. NDVI is calculated by taking the NIR band and the red band. It is the ratio between near infrared minus red band and near infrared plus red band. NDVI values range from -1 to +1, wherein values approaching to 0 indicate bare soil or water bodies, whereas the increase in vegetation tend to increase the NDVI values as well. The frequency of the NDVI values in 1920 is much higher than 2020, as we can see that the highest value in 2020 is 0.278, that was 0.307 in 1990. If we see the comparison, we can be very clear about the fact that the pixel values are tending to be high in frequency, and moreover the difference in 20 years is very clear. The density and the extent of vegetation has declined in all these years. Ratio vegetation index is represented by a simple ratio between the NIR band and the red band. It again shows the density, the extent of vegetation, and whether the vegetation is healthy or not. In 1990, we can see that the ratio vegetation index has much higher values. The highest value is 2.3, whereas if to the year 2020, we can see that the highest value is simply 1.77. It again is very clear when we compare both the graphs. We can see that the frequency in 1990 is tending towards 1400s or 1200, whereas the highest frequency recorded in 2020 is simply 600, above 600. Normalized difference built up index has been estimated for 2020. The algorithm of NDBI is shortwave infrared band minus near infrared band divided by shortwave infrared band plus near infrared band. It can be seen that the places which are having higher values of NDBI are the ones which have lower values of vegetation index, and vice versa. We can see the dense forested regions of Bankura have lower values of NDBI. In the final slide, we can see the raster histograms generated from QGIS, which show the GCI, NDVI and RVI values of 1990 and 2020. The frequency of each of their vegetation indices in 1990 is much higher than that of 2020. The depletion in overall leaf chlorophyll content reduces the amount of solar radiation that can be absorbed by the leaves and the plants. It in turn limits the efficiency of photosynthetic process and lowers the plant's health. Individual values are also written here. For example, the highest GCI value in 1990 has been recorded as 0.928, highest NDVI value is estimated to be 0.307, and highest RVI value is 2.30. Each of these values are much higher in 1990. In the previous slide also, we have seen how simultaneously the NDBI values and the values of vegetation indices have differed. So in one line, the finding can be summarized as the concentration of chlorophyll, the extent of vegetation, and the health of plants have deteriorated. That was all. Thank you so much.
Thank you.
Thank you, Anisha, for your presentation. Now we will shift to our second presentation, that is assessment of mangrove degradation due to repeated cyclone in the Sundarbans using satellite-driven canopy density model and vegetation index. That will be presented by Saurabh Samanta. So I would like to request Dr. Twin Bhadra to put up the presentation.
Good afternoon, everybody. My name is Saurabh Samanta. I am a research scholar from School of Oceanography Studies, Jadavpur University. Today, the topic of my presentation is assessment of mangrove degradation due to repeated cyclones in the Sundarbans using satellite-derived canopy density model, vegetation indices, and biophysical variables. Before going to the main discussion, I would like to demonstrate a brief introduction on Sundarban. We all know Sundarban is the largest mangrove forest in the world. This mangrove forest acts like a natural shield to cyclones. Increasing cyclone frequency and intensity in Sundarbans caused significant damage in mangrove forest. We are considering two cyclones of last 2 years for damage assessment in the mangrove forest. One is the severe cyclone storm Bulbul, which wind speed was 130 km per hour and made landfall at midnight on 9th November 2019 between Sagar and Khepupara. And another is very severe cyclone storm Amphan, made landfall at evening on May 20, 2020 between Digha and Hatia. The wind speed of the Amphan cyclone was 155 to 165 km per hour. The objective of this study is to analyze mangrove degradation due to cyclone Bulbul and Amphan using canopy density model, vegetation indices and biophysical variables. And the second objective is to compare the area and percentage of change during pre and post Bulbul and Amphan cyclones. We are considering core and buffer area of Sundarban National Park for this study, and the two cyclone track were overlaid on this map. The Amphan track was moving from south to northward, and the Bulbul track was going from southwest to northeast direction over the mangrove forest. Let's go to the methodology part. We are concentrating three methods for damage assessment that are well-established canopy density model, vegetation indices and biophysical variables. For canopy density model, Landsat OLI image of November 2018, 2019 and 2020 were used for assessing the forest canopy density. This model involves biospectral phenomenon modeling and analysis utilizing data derived from four indices that are Advanced Vegetation Index, Bare Soil Index, Shadow Index and Thermal Index. Principal component analysis was done on Advanced Vegetation Index and Bare Soil Index for vegetation density calculation, and Scale Shadow Index was calculated based on Shadow Index and Thermal Index. Finally, the Scale Vegetation Density and Scale Shadow Index were integrated and canopy density map was generated. There are several vegetation indices, among them Enhanced Vegetation Index, Soil Adjusted Vegetation Index and Green Normalized Difference Vegetation Index were used for health degradation assessment using blue, green, red and near infrared band. For biophysical variables, leaf area index and fraction absorbed photosynthetically active radiation were calculated using neural network based method in biophysical processor tools in SNAP software using Sentinel-2 image. Finally, all the data have compared and the area and percentage has been calculated. Let's go to the result part. This figure showing the Advanced Vegetation Index, Bare Soil Index, Scale Vegetation Density results for the year 2018, 2019 and 2020. Clear declination of values in middle part of the 2019 image and western part of the 2020 image were noted in the Scale Vegetation Density map. In this slide showing Shadow Index, Thermal Index and Scale Shadow Index maps for the year 2018, 2019 and 2020. Declination of value in middle northern part and eastern part in 2019 image and western part of the 2020 image were witnessed in the Scale Shadow Index maps. For canopy density change, 5-class classification have been done in the canopy density model where 0 to 20% is very low canopy density and 80 to 100% is very high canopy density. It was observed that canopy density decreased considerably in the very high density area, that is 80 to 100% area. Changed matrix between 2018 and 2019 showing 68% area has been changed from very high canopy density to to high canopy density between 2018 and 19, and 88% area has been converted from high canopy density to moderate canopy density. Change matrix between 2019 and 2020 showing 70% area has been transformed from very high canopy density to high canopy density, and 9% area has been changed from high canopy density to moderate canopy density. Let's go to the vegetation indices comparison. All the vegetation index have been normalized and compared by subtracting post and pre-cyclone images. From enhanced vegetation index, we are getting 14.6% high loss and 45.8% low loss area during the Bulbul cyclone, and 14% high loss and 51% low loss area have been witnessed between pre and post Amphan cyclones. Green normalized difference vegetation index, we are getting around 13% high loss area and 51% low loss area during pre and post Bulbul image comparison, and 12% high loss area and 40% low loss area have been observed between pre and post Amphan cyclones image. Similar type of result we are getting from soil adjusted vegetation index. 15% high loss area and 47% low loss area during the Bulbul cyclone comparison, and 12.7% high loss area and 51% low loss area have been identified between pre and post Amphan comparison. Among the three indices, it was observed all the indices have account severe health change in mangrove forest, but the loss of mangrove health was little high during Bulbul cyclones. I want to mention one observation along the track of Bulbul. There are little gain in indices values, maybe due to eye of cyclone passed through this zone and less destruction has been created. Let's move to the biophysical part. Leaf area index will get 15% high loss of leaf area and 48% low loss of leaf area between pre and post Bulbul cyclone comparison, and 22% high loss and 51% low loss area have been identified between pre and post Amphan cyclone comparison. Photosynthetically active radiation also showing 8.6% high loss area and 44% low loss area during the Bulbul cyclone, and 7% high loss area and 59% low loss area have been noted between pre and post Amphan cyclones. The decreasing area of biophysical variables indicates loss in canopy structure and net primary productivity in Sundarbans. Now I would like to summarize the main points. All the methods are showing severe damage in mangrove canopy area and health during these two cyclones. So remote sensing technique can be applied for damage assessment after cyclones. And this study indicates that the increasing frequency of high intensity cyclones in the Bay of Bengal is likely to have adverse consequence on the health of the mangroves of this World Heritage Site in the future. These are some field photographs of mangrove damage after Amphan cyclones taken this 29th November to 1st December 2020 in Bali Island. These are the reference. Thank you all.
Thank you, Saurabh.
Thank you, Saurabh, for your presentation. Now we will shift to our third presentation, that is again related to mangrove environment of Sundarban. And the title of this presentation is Mangrove Forest Cover Change during 2000 to 2019 in Sundarban of India and Bangladesh using remote sensing techniques. The presentation is developed by Piali Sarkar, Deblina Sarkar, Ortho Ghosh, and Manoj Kumar Nanta. So I would like to request Dr. Twin Vadra to put up the presentation, please.
A
A very good morning to everyone. I am Deborina Sharkar, presently pursuing my doctoral degree from Bidhan Chandra Krishi Vishwavidyalaya. Today I am going to present on the topic of mangrove forest cover changes during 2000 to 2019 in Sundarban of India and Bangladesh using remote sensing techniques. We all know that Sundarban is one of the richest ecosystems in the world. It covers almost 10,000 km² area stretching from India to Bangladesh. It provides a wide range of ecosystem services and contributes to socio-economic development of the neighboring countries. But climate change induced degradation, over exploitation of timber, sea level rise, coastal erosion, increasing salinity, increasing number of cyclones and storm surges threatens the mangroves of Sundarban. Nowadays, the monitoring of this biodiversity is very much essential. The trend of forest density change in spatio-temporal scale can be successfully monitored using satellite-based remote sensing technique. Keeping this in view, the present study was conducted in the Sundarban mangrove forest area to analyze the time trend of mangrove cover and its association with vegetation index and rainfall from 2000 to 2019. The study has mainly three objectives. Firstly, to study the pattern of spatio-temporal distribution of rainfall. Secondly, to study the spatio-temporal trend of tree cover in the mangrove forest region. And lastly, to assess the dynamics of vegetation condition of Sundarban's mangrove region using Moody's Composite Vegetation Index. This is the map of Sundarban mangrove cover area. 60% of the total study area is in Bangladesh. The study was conducted for the period of 20 years from 2000 to 2019. So this is some data and their sources. Moody's vegetation data is used for estimating annual tree cover percentage. For calculating NDVI, we use 16-day composite of Moody's derived NDVI data product. ERA5 atmospheric parameter archive data has been used for calculating monthly total rainfall. The open source softwares like QGIS, Saga, and an advanced cloud-based geospatial processing platform that is Google Earth Engine are used for this study. The presence of monotonic increasing and decreasing trend in the Moody's NDVI time series and the tree cover percentage is tested with non-parametric man-candle test. This is the block layout of the study area. The whole Sundarban mangrove region was divided in 24 blocks and the dimension of each block is 900 km². The results are also divided in three parts. Firstly, spatio-temporal variation of rainfall in Sundarban. The monthly rainfall aggregates were collected from ERA5 data product. To evaluate the spatial variation of seasonal and annual rainfall, rainfall received from 2000 to 2019 was averaged for each working blocks. Mean rainfall received by the blocks during the entire study period along with the coefficient of variation has been presented in this table. The period extending from March to May was considered as pre-monsoon season. In this season, R3C6 block received the highest rainfall, whereas R1C1 received the lowest rainfall with maximum variation. During monsoon, that is June to September, R1C2 received highest and R4C5 received the lowest rainfall. In the month of October to February, that is the post-monsoon, the rainfall varied from 114 to 151 mm. Pre-monsoon rainfall decreased in east to west direction. Higher rainfall was recorded in eastern blocks than the southwestern part. In the monsoon season, rainfall also increased in the north to south direction. The southern blocks received higher rainfall than the northern one. In post-monsoon season, the trend is clearly visible. The southern blocks experienced higher rainfall than the northeastern ones. Rainfall. So, all during the study period, monsoon rainfall varied from 893 mm to 1397 mm. The mean annual rainfall received during the entire study period was 1840 mm, out of which 63% was received during the monsoon. As per the second objective, spatio-temporal trend of vegetation cover is also studied. In order to estimate the change trend of vegetation cover in Sundarban mangrove forest from 2000 to 2019, Moody's data product has been used. Three bands containing the percentage of tree cover, non-tree vegetation and non-vegetation in each pixel were used in the present study. The entire study period was divided into 4 quarters, that is 2000 to 2004, 2005 to 9, 2010 to 14, 2015 to 19. In the first quarter, the density of tree vegetation varied from 16 to 45%. In the second quarter, the maximum density was observed in R4C6. In the third quarter, eastern blocks accounted for the higher tree vegetation, and in the last quarter, that is 2015 to 2019, higher tree vegetation densities were observed in the eastern blocks. The figure represents the spatial distribution of average tree cover percentage in different quarters of the study period. During the entire study period, the non-tree vegetation and no vegetation also studied. The density of the no vegetated areas decreased in west to east direction. This figure represents the changed trend of vegetation cover during the study period. Tree vegetation cover ranged between 19.8 to 36.5%, whereas non-tree vegetation area varied from 8.4 to 11.2%. The detailed trend is explained in the form of regression equation based on sense estimate for which Mann-Candle test was found significant. Three blocks R1C1, R2C1 and R2C2 in the Indian Sundarban region showed highly significant trend with a positive value of sense slope. The highest slope value was observed in the block R2C1, which indicated the maximum percent tree cover increase in the last 2 decades. So the increase of mangrove tree cover percentage in these blocks might be a consequence of conservation and new plantation initiatives taken by government and non-governmental organizations in the last 2 decades. This is the linear trend of mangrove blocks at different level of significance. As per the third objective, we studied spatio-temporal trend of NDVI in mangroves of Sundarban. To study the association of vegetation index with mangrove cover changes, Modius-derived 16-day composite NDVI data product were used. While studying the seasonal pattern of NDVI, the lowest NDVI median values were observed in the month of June to July. Minimum values may be due to less aerial growth or pest disease infestation. There was a monotonic trend of NDVI in R2C1 block, and it was highly significant with a positive sense slope value. This is the temporal pattern of NDVI median in R1C1, R2C1, R3C4 and R4C6. The forest block R2C1 has the monotonic trend of NDVI with 1% level of significance with a positive sense slope value. It implies that vegetation growth of mangrove increased over year. This is the change trend of annual average of NDVI median in 4 blocks. It can be concluded from the study that the temporal variability in the monsoon rainfall was comparatively lower than the spatial variability. Seasonal as well as annual rainfall occurred from 2000 to 2019 over the study area was widely variable. A sinusoidal pattern of seasonal and annual rainfall was found. Density of tree vegetation was higher in the eastern blocks and lower in the western part. Tree vegetation densities started to increase after 2005 to 2009 period, and this trend continued up to the end of the study period. In all the working blocks, maximum values of NDVI median were seen in the months of October, November and December. These are some of the references of my study. Thank you for your kind attention.
Thank you very much.
Thank you, Devlena, for your presentation. Now, again, we move to the fourth presentation for our technical session 4, that is mangrove monitoring and application of Google Earth Engine for big geo data processing by Momita Maiti. So I would like to request Dr. Twin Bhadra to put up the presentation.
Hello everyone, I am Momita Maiti. Now I am talking about mangrove monitoring and application of Google Earth Engine for big geodata processing. Mangrove is the most productive ecosystem in the world, which is shown dominantly in the intertidal zone of tropical and subtropical zone. Mangrove ecosystem has great contribution to environment as it can sink CO2, reduce global warming, protect coastal erosion, serve human from different way. It is estimated that about a third of mangrove forests have been lost during the last century. So, challenges in mapping mangrove ecosystem, it needs for high resolution imagery, and cloud cover is a big issue, and then high and low tide impact the characteristics of signal to mangrove monitoring. So objective of my study, process and analysis of radar data, mangrove change monitoring, and estimate of above ground biomass of mangrove forest. So whether a surface appear rough or smooth to the radar depends on the wavelength and the incident angle. Surface is considered as a smooth if the light variation are much smaller than the radar wavelength. As a useful rule that the higher the backscatter signal, the rougher the surface will look like in the image. Mainly in mangrove ecosystem, volume and double bound scattering occurs. Double bound scattering is seen in inundated vegetation or trees standing on water. Signal backscattered very highly because signal bounce of the water, which is specular reflection of the water underneath of the vegetation, and it bounces onto the tree trunk or other component of the tree and bounces back to the satellite. It appears very bright in the radar image. Then radar signal interacts and backscattered from different part of vegetation. As you can see the image. So there are three types of scattering mechanism in the mangrove ecosystem. These are single or direct bounce in white colored in the image, volume in white, and double bounce in red. The dominant scattering mechanism strongly depends on canopy structure and volume. Double bound scattering is very much more than other types of forest, particularly mangrove. Volume scattering decreases in the closed canopy and double bounds increases in open canopies. Inundated at the time of data acquisition also can have impact on the radar signal in open mangrove forest. This table is very nicely summarized of the general penetration depth and dominant scattering mechanism in mangrove forest in different bands. Example, L-band microwave penetrate into the canopy is about as larger as half of canopy height. Scattering is dominated by single or direct bounds in the tall forest and volume dominates in the shorter sharp mangrove. Double bounce, which means backscatter, will be very high, increases significantly lower biomass and the more open the forest. At the shorter wavelength, such as C-band, for example, penetrate in depth goes about one-third of the top of the forest height, and scattering mechanism will consist to single direct bounce and volume scattering from upper canopy with small surface and double bounce component. This double bounce component increases in open forest and low biomass areas. This table contains the backscatter range from mangrove from different brand and polarization. These are general trends and may not be constant. Among different polarization, example HB polarization is dominated by volume scattering, and HH and VV polarization has contribution for the ground because they can penetrate deeper through the canopy than cross polarization. HH is particularly sensitive to the inundated vegetation affected by double bound scattering. Double bound strongly impacts HH channel may be reduced by presence of roots or carved root that are distinctive in mangrove forest. L-band backscatter at both HH and HB polarization is lower than other vegetation. It is why mangrove look like darker than other vegetation in L-band and HH and HB polarization. If we have multiple polarization, can we can use them identify mangrove forest from other land cover classes, especially at longer wavelengths. So it is very difficult to map the extent of mangrove forest using radar alone, in particularly when the adjacent island covered by forest or subland because of a similar backscatter manner. This is also very difficult with optical sensor alone because greenness may not be sufficient to distinguish mangrove from other vegetation. Land cover classification can generally be performed with radar backscatter as one of the layer along with data from optical instrument. As example, Landsat Sentinel-2. There are Google Maps of mangrove extent derived from optical data that can be used to extract the area of mangrove forest from radar data. It is generally more efficient to start with existing but reliable remote sensing product with mangrove and improve upon those with the radar data utilized. Example, mangrove are likely to occur in sloping ground and elevation above sea level higher than 10 meters. So the baseline map can initially establish where mangrove occur within some sort of reference, and we can refine the baseline based on the changes within area. It is most likely to occur, then quantification of change of the mangrove can be done using radar data. Data uses for study: ALOS Pulsar 1, ALOS Pulsar 2, GERS1 mosaics, Global Mangrove Watch 2010, and software used here: Snap for image processing and Google Earth Engine cloud computing platform for image classification. In the study, area of interest is Sundarban mangrove forest area, which is located in the southeast part of West Bengal, India, and more part covered in Bangladesh and surrounded by Bay of Bengal in south. Now it is the methodology of my work. First, GERS 1996 radar HH with HH polarization dataset downloaded from JAXA web page. Then global mangrove distribution vector imported in GEE. Yearly mosaic pulsar dataset of 2007, 2010 and 2017 imported in GEE from GEE repository. All images have been processed and analyzed, then clipped on ROI, means region of interest. Then image rationing have done to image analysis and visualization. Rationing image of 2007 to 17 and 1996 to 2017. After visual interpretation and overlaying known mangrove vector layer on the rationing image, pixel or polygons for change detection as loss, gain, persistence of mangrove for respectively 1996 to 2017 and 2007 to 2017 years. Extract the statistics, example mean and standard deviation of the polygon of the 6 classes, taking the statistics to set the limit of threshold to apply on a rationing image. So if the pixel value of the rationing image is greater than threshold value of loss pixel class of particular same rational image, these pixels are classified as mangrove loss pixel. And oppositely, if the pixels value of the rationing image is lesser than threshold value, then it is classified as mangrove gain pixel. Then to know the mangrove distribution of respective years 1996, 2007 and 17, firstly clip the original unclipped radar image year-wise, then use mangrove file which extracting the backscatter only over the area where vector file is indicating presence of mangrove. then we can get backscatter for different year and polarization of the area where the mangrove vector file indicated mangrove. So now it is result of my study. In this map, we can see mangrove loss and gain into temporal duration from 2007 to 2017. Here, mangrove loss and gain change can detect 1996 to 2017. Here you can see clearly the changes of mangrove. In this image, we can see the changes of mangrove distribution shown in 1996, 2007 and 2017 respectively. To estimate of about ground biomass of mangrove forest, firstly SRTM DEM data is clipped to the known mangrove vector. There is a relationship between canopy height and mangrove biomass. DEM is vegetation height in some places where signal is not penetrating all the way through. Especially in mangrove ecosystem, the signal is not reaching the ground. SRTM really is measuring the basal area weighted height based on the allometric or generic equation. When assessing of the actual elevation of mangrove with SRTM, we know mangrove grows in coastal flat area. So as SRTM telling height along coast about height, it is actually mangrove height. Here I inspect the elevation and biomass of mangrove of a location. It is mangrove elevation and biomass are respectively 5 meter and 42.90 tons per hectare respectively. So in future, I have planned to explain the causes of mangrove degradation or loss with temporal basis. This time I want to use machine learning techniques as random forest decision tree, support vector machine etc. To image classification, which algorithms are present in Google Earth Engine in build. So mangrove forest for our mother earth is very important ecosystem from environmental, climatic, anthropologic point of view. There are different issues for mangrove identification and mapping. For its typical location, different image collection time etc. It needs images from different satellite sensors to get better result in mangrove study. For big geodata processing, Google Earth Engine is better choice for having parallel computing in cloud environment with big geodata repository and machine learning algorithm and other much more facilities. So these are my reference and thank you.
Thank you, Momita, for your nice put up. Now we are headed towards the penultimate presentation, which is titled with the carbon emission estimation of Sundarban Delta using Landsat data, which will be presented by Milan Shamanto. And I would like to request Dr. Twin Bhadra to put up the presentation.
National Conference on Geospatial Science for Digital Earth Observation 2021. Now I am going to present about carbon emission estimation for the Sundarban Delta using Landsat data 1995 to 2015. Overall content is introduction, motivation, literature review, study area, objective, data use, methodology, result, conclusion, and reference. Introduction. Carbon dioxide play an important role in climate change. Carbon emissions are mainly from human activity, including fossil fuel burning and land use change. The study provides us with land use data and method for estimating carbon emission. Satellite data remain to be used as an important land use information sources. This study focuses mainly on the carbon emission characteristic of various elevated fields. Also monitor land use carbon emission by means of Landsat satellite image data. Motivation. As the world rapidly developing country, India has made 3 commitments under the Paris Agreement. Number 1, Indian greenhouse gas emission intensity of its GDP will be reduced by 33 to 35% below 2005 level by 2032. 40% of Indian power capacity would be based on non-fossil fuel sources. 3. India will create an additional carbon sink of 2.5 to 3 billion ton of CO2 equivalent through additional forest and tree cover by 2030. Carbon emission estimation for the Ganges River Delta urban agglomeration using 1994 to 2016 Landsat image data. They have used the satellite data of Landsat 5 and Landsat 8 and the energy consumption and GDP data they use. Method and result. Number 1, land use random forest classification and accuracy assessment, carbon emission from land use and energy consumption and carbon intensity. Number 3, global and local spatial autocorrelation model and find out hotspot and cold spots. Study area. The Sundarban is a mangrove area in the delta from by the confluence of Ganga, Brahmaputra and Meghna river in the Bay of Bengal. The present study of India Sundarban lie among the South 24 Pargana district of West Bengal between the latitude 21 degree 30 minute to 22 degree 30 minute north and 80 degree to 89 degree 7 minute east. Objective to find out carbon emission characteristic of various LULC field and second to monitor land use carbon emission and carbon absorption. Research question 1. How much carbon dioxide will be emitted or sink per 10-year interval from individual land cover type? Number 2. Which land cover type will make carbon emission or sink? Software use. Software use such as QGIS, ArcGIS, Adamas, and also Google Earth and Google Map are used. Detail of Landsat data which used for the study area. For Landsat 8, band 1 to band 7 and band 9 have 30 meter resolution and band 8 band chromatic have 15 meter resolution and band 10 and 11 thermal band have 100 meter resolution. For Landsat 7, band 6 have 60 meter resolution and band 8 have 15 meter resolution and all band have 30 meter resolution. For Landsat 5, band 6 have 120 meter resolution and all other band have 30 meter spatial resolution. Methodology to be used. I collect Landsat 5, Landsat 7 and Landsat 8 data, then make pre-processing of this satellite data such as atmospheric correction, noise removal, geometric correction, then define extent study area, then subset study area, then applied supervised image classification method, then create accuracy assessment and derive of land use and carbon emission calculation applied. This is the land use land cover map of 1995, 2005 and 2015 year. Accuracy assessment. Accuracy assessment is an important part of any classification project. It compares the classification image to another data sources that is considered to be accurate or ground truth data. K is equal to P0 minus P upon 1 minus PE, where P0 is the observed increment and PE is the expected increment. I have created the accuracy assessment of Landsat image data, also omission error, commission error, user accuracy and producer accuracy calculated. Overall accuracy is 0.93 and kappa value 0.19. For the Landsat 7, overall accuracy is 0.94 and kappa value 0.92. For Landsat 5, overall accuracy is 0.91 and kappa value is 0.88. Percentage of changes of cropland and forestland area is decreasing and water area and built-up area is increasing. Overall trend of cropland area is rapidly decreasing. Forestland slightly decreasing. Water area and built-up area is rapidly increasing. Calculation of carbon emission. EI is equal to SI into sigma into MCO2 by MC, where EI is the carbon emission from land use. I refer to the type of land use. SI is the area of land I. Sigma I is the carbon emission coefficient for land I, whose positive value indicate carbon emission, whose negative value indicate carbon absorption. MCO2 by MC is the ratio of the mass carbon dioxide molecule to a carbon atom. This is the carbon emission coefficient value of cropland, forestland and wetland which used in the study area. Carbon emission from the cropland area is decreasing. Negative sign indicates the carbon absorption, whereas positive sign indicates the carbon emission. Total carbon emission is decreasing and total carbon absorption is increasing. From the 1995 to 2015, total carbon emission reduced and total carbon emission increasing and net carbon emission is decreasing. Conclusion. Carbon emission characteristics provide to policymakers to formulate carbon emission and reduction policy. The study focused on remote sensing based carbon emission estimation for the Sundarban region over 2 decades from 1995 to 2015. Forest land and wetland are absorb the carbon, whereas cropland are emit the carbon. This is the reference, and thank you.
Thank you, Milan, for your presentation. Now we are at the brink of our end of this technical session, and which will be concluded with the final presentation of Subroto Mitra. The title of this presentation is GIS-based Valuation of Ecosystem Service in the Lower Delta Plain of West Bengal with special reference to Indian Sundarbans. I would like to request Dr. Tuhin Bhatto to put up the presentation.
Good afternoon, sir and madam. This is Subroto Mitra, and I am at present pursuing my PhD degree from Department of Geography, Adamas University. Today, I would like to present my paper entitled as GIS-based Variation of Ecosystem Services in the Lower Delta Plain of West Bengal with special reference to Indian Sundarban. The Millennium Ecosystem Assessment Report 2005 defines ecosystem services as benefits people obtain from ecosystems. The ecosystem services are classified as number one, provisioning services, that is products obtained from ecosystem. Number two, regulating services, benefits obtained from the regulation of ecosystem. Number three, cultural service, that is non-material benefits that people obtain through spiritual enrichment, recreation, etc. And number four, supporting services, that is necessary for the production of all other ecosystem services. Food, fiber, fuel are provisioning services. Water regulation, cultural regulation are regulating services. Spiritual enrichment, cognitive development, recreation are cultural services. And soil formation and retention, nutrient cycling, primary production, water cycling are supporting services. This is the study area which a part of Ganga-Brahmaputra Delta and includes North and South 24 Pargana district of West Bengal. There are four major flow-dependent ecosystems in the study area. These are the mangrove ecosystem, the riverine ecosystem, which further may be subdivided into freshwater and saline water tidal blocks, the estuarine ecosystem, and the floodplain freshwater wetland ecosystem. Each of these ecosystems performs a variety of ecosystem services like drainage, navigation, sediment flushing, shoreline stabilization, preventing of salt intrusion, storm protection, recycling of organic nutrients, carbon sequestration, food and other resources supply, etc. Provisioning of nourishing breeding ground for aquatic animals is a major service of these ecosystems. The ecosystem services increase and decrease depending on flow availability of upstream. The major problems of the study area are the rivers are saline in nature and shallow groundwater is also saline in the southern part of the study area. Most of the rivers have lost their connections with their parent rivers. Saline rivers and salinization of soil and aquifer make agriculture difficult in the south. The disconnected river channels are rapidly transforming into agricultural fields, aquacultural farms. The disconnected rivers are unable to provide ecosystem services due to unavailability of freshwater flow from upstream. Scarcity of freshwater makes it very difficult for the people to secure life and livelihood. Research question of the study area are: is the land use in lower delta plain of West Bengal and Indian Sundarban changing with time? What are the values of ecosystem services in lower delta plain of West Bengal and Indian Sundarban? How does the value of ecosystem services in lower delta plain of West Bengal and Indian Sundarban changing with time? The main objective of the studies are to access the land use, land cover, change dynamics in lower delta plain of West Bengal and Sundarban, to estimate the ecosystem service values in lower delta plain of West Bengal and Indian Sundarban, to access the change of ecosystem service values in lower delta plain of West Bengal and Indian Sundarban with time. These are some important literatures where geographical information system has been used to estimate the valuation of ecosystem services. I mainly followed the method proposed by Costanza in my study. To access the ecosystem service value from land use land cover information, the land use land cover maps were prepared through supervised classification using Landsat images for the year 1990, 2000, 2010, and 2020. Accuracy assessment was done to estimate classification accuracy. The change reduction analysis was performed and area under each land use class was estimated using GIS platform. Land use class-wise ecosystem service values per unit area were taken from Costanza et al. 1997, and this per unit area value was multiplied by the total area under each class, which was derived from the land use maps. Change of ecosystem service values was also estimated under this study using land use land cover change information. Landsat TM5 image is used to prepare land use land cover map of the study area for 1990. There are 5 major land use land cover classes in the study area. These are water, agricultural land, fallow land, vegetation, settlement, waste. After ground truth analysis, it is found that the average user accuracy value and average producer accuracy value is 91% and kappa coefficient value is 0.89. Landsat 7 ETM image is used to prepare land use land cover map of the study area for 2000. There are 5 major land use land cover classes in the study area. These are water, agricultural land, fallow land, vegetation, settlement, and waste land. After ground truth analysis, it is found that the average user accuracy and average producer accuracy value is 94% and kappa coefficient value is 0.93. Landsat 7 ETM image is used to prepare land use land cover map of the study area for 2010. There are 5 major land use land cover classes in the study area. These are water, agricultural land, fallow land, vegetation, settlement, waste land. After ground truth analysis, it is found that the average user accuracy value is 93% and average producer accuracy value is 94% and kappa coefficient value is 0.93. Landsat 8 OLI TIRS image is used to prepare land use land cover map of the study area for 2020. There are 5 major land use land cover classes in the study area. These are water, agricultural land, fallow land, vegetation, settlement, and wasteland. After ground truth analysis, it is found that the average user accuracy value is 90% and average producer accuracy value is 90% and kappa coefficient value is 0.88. This slide shows the land use land cover change between 1990 and 2000. More than 130 square kilometer agricultural land was converted into settlement area during this time frame. Almost 140 square km vegetation area was converted into agricultural land and fallow land. More than 50 square km dense forest became degraded forest during this period. This slide shows the land use land cover change between 2000 and 2010. Almost 200 square kilometer agricultural land was converted into settlement area during this time frame. More than 50 square kilometer water lands converted into agricultural land and more than 100 square kilometer vegetation area converted into agricultural land. More than 130 square kilometer dense forest became degraded forest during this period. This slide shows the land use land cover change between 2010 and 2020. More than 250 square kilometer agricultural area was converted into settlement area during this time frame. More than 50 square km water land converted into agricultural land, and more than 150 square kilometer vegetation area was converted into agricultural land. Almost 150 square km dense forest became degraded forest in this time period. This slide shows the land use land cover change between 1990 and 2020. More than 300 square kilometer agricultural land was converted into settlement area during this time frame. More than 340 square kilometer vegetation area was converted into agricultural land during this time frame. More than 170 square kilometer dense forest area became degraded forest area in this time period. The bar graph shows the maximum ecosystem valuation come from waterland area in the year 1990, and the value is around $1,000 million. The bar graph of Sundarban reveals that maximum ecosystem services are provided by the water body and forest. The bar graph shows that the maximum ecosystem valuation come from water land area in the year 2000, and the value is around $1,000 million. The bar graph of Sundarban reveals that the maximum ecosystem services are provided by the water body and forest. The bar graph shows that the maximum ecosystem valuation come from waterland area in the year 2010, and the value is around $900 million. The bar graph of Sundarban reveals that the maximum ecosystem services are provided by the water body and forest. The bar graph shows that the maximum ecosystem valuation come from waterland area in the year 2020, and the value is around $750 million. The bar graphs of Sundarban reveals that the maximum ecosystem services are provided by the water body and forest. The slide reveals that the ecosystem value of water and dense forest are decreasing day by day. It was $1,050.6704 million for water in 1990, $1,018.91 million in 2000, $918.6338 million in 2010, and $767.3694 million in 2020. Similarly, for Sundarban's mangrove forest ecosystem, the value was $2,039.958 million for in 1990, $1,977.021 million in 2000, $1,827.171 million in 2010, and $1,793.205 million in 2020. This slide shows that the ecosystem service value is maximum for water regulation and water supply in the upper part of the study area, though the value is decreasing day by day. For Sundarban part, ecosystem service value is maximum for nutrient cycle and waste treatment in the upper part of the study area, though the value is decreasing slowly. In conclusion, the value of ecosystem services are the highest for freshwater body, including river, estuaries, mangrove, and non-mangrove forests. Ecosystem service like water regulation, water supply are very high in upper part of the study area. The study finds that the area of dense forest has decreased with the passage of time, and the area of settlement has increased. It has an adverse effect on the ecosystem services of the study area. Ecosystem services like nutrient cycle, waste treatment are very high in Sundarban estuary and mangrove forest area. The total ecosystem service value of the freshwater body in the upper part has changed from $1,050.6704 million in 1992 $767.3694 million in 2020. Similarly, the ecosystem service value of the estuary has changed from $3,299.224 million in 1992, $3,239.861 million in 2020. The total good system service value of the forest in the upper part has changed from $109.7877 million in 1990 to $97.869 million in 2020. Similarly, the value of mangrove forest ecosystem has changed from $2,039.958 million in 1990 to $1,793.205 million in 2020. The health of the mangrove forest is deteriorating with increasing salinity level of the estuarine rivers, and the area of the forest is also decreasing. Therefore, the shrinking forest is unable to provide services like past. Thank you.
Thank you, Subrato, for your presentation. Now, I would like to open the forum for question and answer. If any of you have any question, you can write it down on the chat box or ask the participant directly. So as there is no question in the chat box and no other participants have asked the question, I would like to conclude the session. And the session started with a presentation by Anusha Sarkar and Priyadashini Bhattacharya on the topic, which is assessment of vegetation health using remote sensing data set on forests of Bankura districts. They have used different indices using different wavelengths of remote sensing data. Mostly the Landsat data has been used for this analysis to underscore the vegetation health of the study area. After that, we found very interesting assessment of vegetation health of Sundarban area using canopy density model and other vegetation index by Saurabh Samanto and others. Saurabh has studied the impact of different cyclones and the cyclone induced vegetation degradation of Sundarban area. Then we looked into the mangrove forest change in between 2000 and 2019 in Greater Sundarban, that is part of both India and Bangladesh, using remote sensing data. The presentation put up by Dublin Sarkar of Vidhan Chandra Krishi Vishwavidyalaya. They have used different methodologies to identify the spatial variation of rainfall, spatial variation of the density of vegetation, and also try to look into the different indices using remote sensing data product to underscore the change in the vegetation cover of Sundarban area, both India and Bangladesh. Then we looked into the application of Google Earth Engine as a platform to analyze the mangrove settings or mangrove vegetational coverage of Sundarban area again. Moumita has elaborately put up her presentation in the way that Google Earth Engine is one of the emerging platform for mangrove monitoring using the big geodata. After that, we looked into the carbon emission estimation of the Sundarban area using Landsat data by Milan Samanto and RNK Sharma. They also used Landsat data product and the global data value to estimate the carbon emission which is been measured using the Landsat data product. Finally, we've calculated. We have seen the calculation of ecosystem service of Indian Sundarban using GIS methodology by Subroto Mitro. He has measured the different ecosystem service using the global value, mostly the application of different service values by Costanza, and how these services, provisional service and the recreational service, are available with the Sundarban mangrove forest, and their estimation in monetary terms has been found. So with these points, I would like to thank our resource person, Dr. Sugoto Hazra sir, for his kind presence within this platform. And I would like to transfer the podium to Dr. Tuhin Bhadro for further points that he would like to make.
Thank you, Dr. Rajiv Sharkar, and I do not have any further points to add. So I'd like to thank Dr. Professor Sugoto Hajra for his presence, and sir, we have received your marks. Thank you very much. And now I'd like to ask Dr. Kosturi Mukherjee to start the next session.
Thank you, Tohi. And thank you, our honorable speaker and all the presenters, participants present here. So now we are at the end of our conference, and I'm really thankful to the organizer from Indian Society of Remote Sensing, and the convener from Adamas University, Dr. Tuhin Bhadro, for organizing such a big event in a nice way. And in this valedictory session, we have with us Professor Bimal Kumar Sharkar, former Dean, School of Basic and Applied Sciences at Adamas University. I would like to request you, sir, to chair this session.
Yes.
So first, sir, I would like to request you to say a few words and inaugurate this valedictory session.
Thank you very much, Dr. Kosturi Mukherjee. And
Sir, you are
really,
not audible to us.
Hello, is this okay? Am I audible?
Yes, you are audible.
Yes, you are.
Yes, sir.
Oh, so thank you very much. And really, this time is very remarkable time that we are at the end point of this conference, international conference on geospatial science for digital Earth observation, that is GSDEO 2021. I should not say this is the end point. I should just say that this is basically the continuation of this activity, which really great activity done by the Department of Geography, School of Basic and Applied Sciences, Adamas University, in association with Indian Society of Remote Sensing, Kolkata chapter. Because this event is so grateful, which covers the all aspect of geospatial on the digital Earth observation. Really, the significant name given that digital Earth, and where we can use the different technique and different process which are followed for the exploration of many things, which includes different aspects in interdisciplinary way. So this is a great event. In that respect, it's a very great moment for the Department of Geography, School of Basic and Applied Sciences. I should not say only the Department of Geography here involved interdisciplinary, different aspect, different field also. And rightly says, we are very thankful to the very big organization, and proud for us that they have accepted our this concept, that the Indian Society of Remote Sensing also. And today, actually, at this point, we have just learned with us, about 75 participants from over 50 universities have participated, and it covers different aspect of just geoinformatics in geomorphology, which includes the application of geoinformatics in geomorphology, and then also hydrology, urban science, land use planning, climate, environmental studies. And here we are very happy that so many big eminent scientists and speakers given their thought here and share knowledge. The participants really find a very good space that they can share their thinking and also their work with everyone. So in that respect, this event is very grand success, I should say. And we are very happy that we are also just a moment here, we're associated with this event. So now the session is for validity session, and here the different aspect again will be explained, will be briefed. So I'm very thankful that Dr. Kasturi Mukherjee also given me an opportunity to say something about this event. And over to Kasturi Mukherjee, please.
Thank you, sir. I would like to now request Professor Pradeep Shikdar, Vice Chairman of Indian Society of Remote Sensing Kolkata chapter, to give a brief overview of the technical sessions that we had.
Okay, thank you, Kasturi. Respected Professor Bimal Kumar Sharkar, Chairperson of this valedictory session, and he is also the former Dean of School of Basic and Applied Sciences of the Adamas University, Dr. Dibendu Dotto, General Manager, RRSC East, ISRO, Kolkata, delegates and participants from various parts of the world, faculty colleagues, dear students, ladies and gentlemen. At the outset, I'd like to thank the organizers, for giving me this opportunity to brief about the outcome of this conference, and also what are the basic recommendations that came out from this conference. Now we had 2 grand days of knowledge sharing among 75 participants from more than 50 universities on geospatial science for digital Earth observation, which includes acquiring raw digital data for the Earth, data standard, interactive operating techniques, voluminous data storage and compression, distributive objective technique, spatial data warehouse, virtual phenomenon knowledge and distributed intelligence, graphic search engine, WebGIS, and various kinds of application models. Only Earth observation technology from the space can provide global, repeated, and continuous data covering the Earth's surface. I'm also happy to inform you that this year, that's 2021, is also the Silver Jubilee year of Indian Society of Remote Sensing, Kolkata chapter. And this GSDEO 2021 is the first conference in the Silver Jubilee year, and we are privileged to have Adamas University as a co-organizer of this second international conference. 44 papers, I believe, were present in 8 technical sessions covering 4 major areas: geomorphology and hydrology, urban science, social sustainability and land use planning, and climate and environment. There were 3 poster presentations. Many of these papers were of very high standard. The delegates also responded with many thought-provoking questions, which were eruditely responded by the authors. The conference theme was very well discussed in the inaugural session by Engineer Subrato Haldar, the chairperson of ISRS Kolkata, Professor Naveen Das, Vice Chancellor, Adamas University, and Professor Jitendra Kumar Pandey, Dean, School of Basic and Applied Sciences, which set the tone of the 2-day international conference. There was also a special lecture delivered by Dr. P. Chakraborty, who is the former Chief Scientist, Department of Science and Technology, Government of West Bengal. In his erudite speech, Dr. Chakraborty talked on geospatial technology and hydrological studies and focused on the use of this technology in water resource management. Apart from this, there were 8 keynote talks on the 4 themes. The deliberations of this conference have brought to light some pertinent issues and problems in digital Earth observations. The main recommendations that emerge from this two-day conference are, what I'm going to do, I'm going to, brief the main recommendation in technical session wise. So the first technical session was on geomorphology and hydrology. And the first recommendation was re-engineer the understanding of geomorphology using new range of remote sensing techniques such as LIDAR, advanced satellite platforms, etc., that may lead to dramatic increase in terrain information and provide new opportunities for a better understanding of surface morphology and related Earth surface processes. Number two, develop innovative methods for exploiting satellite observations in monitoring hydrological and hydraulic variables, that is rainfall, soil, moisture, water depth, water quality, flow velocity, and river discharge, and evaluate their potential in modeling of the hydrological and hydraulic phenomena. The main recommendations of technical session 2, that was on urban science, are: number one, focus on integration of heterogeneous remote sensing data, primarily for investigating or modeling urban environment as a complex system. Develop new algorithms for effective extraction of urban features. Number three, improve the accuracy of traditional spectral-based classification algorithms for addressing the spectral heterogeneity within urban areas. And number four, more use of remote sensing for planning, operation, and maintenance of energy infrastructures, in particularly the ones with spatial variability such as solar, wind, and geothermal energy. The recommendations of technical session 3, that is social sustainability and land use planning, are: number one, GIS and RS is a quicker and cost-effective analysis of land use planning with accuracy, and in combination with field data can provide a unique and hybrid database for optimal mapping of land use and land cover. Remote sensing plays a major role in the development of environmental monitoring to assist in early detection of epidemics, which is a major challenge for health management. Remotely sensed data can provide valuable source of information at each stage of disaster management cycle, that is reduction, readiness, response, and recovery, which will help to understand spatial phenomena and provide objective data source for decision making. Number four, scientific understanding of changing mangrove forest cover has greatly improved as a result of availability and accessibility of remotely sensed data, advancement in image processing and classification algorithms, improvement in computing and availability of expertise in handling remotely sensed data. Number five, rational planning of ecotourism activities and conservation measures can be improved immensely through the use of remote sensing with GIS and multi-criteria decision-making in an integrated manner. And finally, the main recommendations of technical session 4, that is climate and environment. Number one, satellite remote sensing and associated airborne and in-situ measurements are critical for advancing our understanding of the global climate system dynamics and its impact. Number two, focus should be given on satellite observations, data analysis, and modeling of urban pollution dynamics of pollutant, hydrological cycle, etc., to understand the changing urban climate in a better way. Number three, combination of moderate and high resolution data can provide detailed coastal land use maps implementing coastal regulation measures. And number four, remote sensing data helps to address challenges related to assessing, quantifying, and monitoring near-shore shallow marine and open ocean processes, ecosystem productivity and biodiversity, interrelationships between vegetation and water quality, and the impact of sea level rise. In conclusion, the recommendations actually portray a roadmap to evolve an entirely different paradigm on geospatial science for digital Earth observation to improve the quality of our life and of our generation and generations in future. Thank you and have a pleasant evening.
Thank you.
Over to
yes, sir. You have given a very good technical overview of the outcome of the conference, and I would just like to add that, of course, sir, these lectures, these papers were really good, and we are hoping to get a good number of full paper submission for our next IOP publications from this conference. And now I would like to request Professor Bimal Kumar Sarkar to announce the session-wise best papers. That papers has the awards, this marks has been decided by the chairperson, co-chairperson, and the keynote speakers. So if you can announce the session-wise best papers, Bimal Sharma sir.
Yes, actually, this session already explained and a different session, and now we are in a position to announce the session-wise the best paper award. And I just a request, please speak the name. Dr. Kasturi, just if you have with you, session-wise, just you give the name, then we can announce this.
Okay, sir, we can then share the screen with you, yes, and you can announce this.
Yes, 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 please.
I request Dr. Bhadra to share the screen, and then sir will announce.
So is it visible?
Yes, this is visible now. So technical session 1A, geomorphology and hydrology. And here the best paper awarded as GSDEO 2021-25, assessing the water quality of Indian Sundarbans estuaries using remote sensing techniques. Authors are Suman Chatterjee, Tuhin Bhadra, Prerona Mandal Das, Sanjay Das, Selima Mandal. So it goes to them with the paper ID 25. And then session 1B, geomorphology and hydrology again. The paper ID 09, GSDEO 2021-09, sea level rise and erosion, threats to an estuarine inhabited island of Pathar Pratima, South 24 Parganas. Authors are Rishin Basu Roy, Nilay Pramanik, Masuma Begum, and Arjun Basurai, Devsena Rai Chaudhuri, Anusua Pal, Anushka Chakraborty, Proshun Majumdar. And then technical session 2A, urban science. Paper ID is GSDEO 2021-14. The title is Questions of Urban Livability, a comprehensive assessment of its vitality in the neighborhood scale. Authors Suman Chakraborty, Dipendranath Das. Next session, technical session 2B, urban science. Paper ID is GSDEO 2021-41. Title is Total Population Forecasting at Micro Level and Built Up Area Modeling, a case study of Durgapur region, India. Authors are Suman Chatterjee, Abhinandan Das, Kanishka Sarkar. Technical session 3A, Social Sustainability and Land Use Planning. The paper ID is GSDEO 2021-20. Title is The Quest for Quality Healthcare Service, What We Can Learn from a Settlement-Based Case Study. Author Sharoni Roy, Anurai. Technical session 3B, which covers social sustainability and land use planning. Here, the award given to presentation for the paper ID GSDEO 2021-16. Title is Marigold Floricultural System to ensure farmers' income, food security, and total livelihood. Evidence from Ranaghat 2 of West Bengal in India. Authors are Dipankar Biswas and Rajiv Sarkar. Then technical session 4A, which covers climate and environment. Here, award goes to the paper ID GSDEO 2021-52 with title Assessing the Urban Environmental Quality, a case study of Kolkata metropolitan area, India. Authors are Devlina Paul, Abira Datta Roy, Kasturi Mukherjee. And then technical session 4B, climate and environment. Here the paper ID GSDEO 2021-31 with title Assessment of Mangrove Degradation Due to Repeated Cyclones in the Sundarbans using satellite-derived canopy density model and vegetation indices, with the authors Saurabh Samanto, Sandeep Giri, Abhro Chandra, Sugato Hajra. So this is in the session 4B, Climate and Environment. So these are the award given to the authors of paper presentation in different session. Many congratulations to them, and really it's a great motivation to proceed further and to do work really to explore the knowledge of geospatial informatics, I should say, and congratulations to them with a very big wishes, good wishes for them. Thank you very much.
Thank you, sir, for announcing all the awards, and congratulations, of course, to them. And so I am sure that many of them are present here, and they must be very happy by receiving this award. So we will be sending the awards to the first author, the presenters, and we will be contacting with them eventually. And by 24 hours, within 24 hours, we will be giving you the feedback forms to all the participants. You have to fill up this feedback forms. So now, after this Best Paper Award announcement, I would like to request Dr. Dibyendu Datta, General Manager, RRSC East, ISRO, Kolkata, to give the valedictory address. Over to you, sir.
Am I audible?
Yes, sir, you are audible.
Well, Honorable Professor Sarkar, Professor Sikdar, the organizers, distinguished participants from different locations joining in this event, a very good evening and a warm welcome to this valedictory session. I'm indeed glad to be a part of this international conference titled Geospatial Science for Digital Earth Observation, GSDEO 2021, hosted by Adamas University and the ISRS chapter of Calcutta, and convey my sincere thanks to all concerned. The theme as well as the deliberation of the conference are apt with the time, and it covers most of the areas of the future challenges that I understand. The areas that have been covered include geomorphology and hydrology, urban studies, social sustainability, and land use planning, as well as the climate and environment, a detailed description of which has been given by Professor Sikdar. I'm not going into the details, but at the outset, I convey all the winners today, as well as all the participants, for a very informative deliberations they have given. I was just going through a few days back on 22nd of March, all of you know that ISRS chapter of Kolkata, they celebrated this World Water Day, very important event. The purpose of which all of you know is to raise the awareness of the millions of people. They are living without access of safe water. You all know that the core focus of the World Water Day is to support the achievement of the Sustainable Development Goal number 6, which entails about the water and sanitation for all by 2030. Following 22nd March, the second important event happened on the next day, that is 23rd March. It's the World Meteorological Day, which highlights the importance of the role of peoples in protecting the Earth atmosphere, which has aptly been explained and in detail it has been described in this seminar. In continuation to the above, these two events, this international conference makes this week memorable and it's a very, very happy ending. I'm sure a lot has been discussed about the frontier areas of technologies, anchoring which the society as well as the university is heading towards the digital era, encompassing from digital classroom to location-based services, Earth health monitoring, disaster warning, crop yield forecasting, and many, many more. Several technologies under the umbrella of information and communication technology cater the need of the end users. The conglomeration of the technologies, namely, which has been discussed in detail, the remote sensing, global positioning system, sensor technology, IoT, machine language, and the artificial intelligence has been proven as the most reliable and the consistent method for digital Earth observation, detection of various anomalies, Earth surface process modeling, weather forecasting, and the extreme events, etc. Now, under the Earth observation system, land surface processes coupled with atmospheric chemistry as well as the physical processes usher a new era of understanding of the Earth system sciences. Today, constellation of the low Earth orbit satellites are continuously looking at the Earth's surface and acquiring information at short temporal and high spatial resolution to capture the subtle and the transient changes. This has also enabled mapping of Earth's surface at very large scale for development planning and the logistic requirement. Like as you see these days, the Google map, even a child is also aware of that Google map. Now from the geosynchronous orbit, apart from this low Earth orbit, the geosynchronous orbit, the weather satellites are keeping a 24/7 watch on the atmosphere, various circulation processes, cloud formation, cyclogenesis through the visible and thermal infrared camera. Timely information has enabled saving of thousands of lives. All of us are witness to that, which was unlike during the Bhola cyclone in the year of 1970 or in the Odisha super cyclone in the year of 1999. Thanks to the precise prediction of the cyclone trajectory along with the landfall location and time. A significant milestone in this direction is the International Charter on the Space and Major Disasters, which provides the satellite data on charitable and the humanitarian perspective to relief organizations in the event of major disasters. I have witnessed in recent days during the Amphan cyclone how the various value-added products are poured onto me so that it can be disseminated to the line departments or to the decision makers. So now there is what we call a discipline has emerged, which is called that that's a humanitarian remote sensing. Coming from this weather satellite data, the dedicated ocean satellites are keeping watch on the surface processes, especially the sea surface temperatures, which is crucial for ocean heat content, tropical cyclone development, cyclogenesis, what we say, as well as the intensification of the cyclones while it's passing through the cold porosities. We are doing some studies, like how the Amphan got intensified and completely there was a change in the track. And then the trajectory which you predicted and which actually happened, there's a very close similarity between these two, thanks to the technology. Apart from this, the ocean color sensors, they provide information on the phytoplankton and the chlorophyll concentration, which has immense potential to be utilized for identification of the potential fishing zones. It is already proven since 1985, it is operational. This also has a use of algal blooms, seasonal algal blooms, which are very detrimental for the aquatic fauna. Those who are working with water productivity, they might be knowing, which are also regularly being mapped and monitored by Indian space capabilities on a regular basis. Coming to radar scatterometer, which provides wind-based information over the ocean surface, and those informations when integrated with the cyclone information, it helps in understanding the sustainable wind speed with the advancement of the cyclonic storm. A relatively uncommon use of the satellite is the satellite data is a satellite gravity sensor, which is unique in the estimation of the groundwater storage and depleted areas. I was listening in the morning, Professor Hajra has very nicely pointed out that how it's different kind of measuring device or methodology, that entire scenario get changed, the submergence scenario. Now, there is a relatively uncommon satellite gravity center you all might be knowing, that is the GRACE satellite, which measures basically the liquid water equivalent thickness. And that can be used in estimation of the mass-induced sea level change. The sea level height change is happening either due to thermal expansion or could be more of terrestrial runoff. So if we use judiciously the GRACE-based satellite gravity data along with the satellite altimetry, there is the possibility that we can partition both the steric anomaly, that means which is caused by thermal expansion, as well as the eusteric, which is mostly caused by mass-induced sea level change, that is basically due to glacier melting. Apart from the weather and the multispectral and the radar satellite sensors, a significant number of hyperspectral sensors are also available in the space or as well as the airborne platform. The advantage of the hyperspectral is that they have got a large number of the contiguous narrow band covering almost optical and the near infrared region, through which you can get the fingerprint of the objects. And some of the very advanced use are like coastal water quality, mineral targeting, hydrothermal alteration zoning, plant health quality, as well as many more. It depends. It is basically, we have not unraveled, the potential of that hyperspectral remote sensing. Another area of the remote sensing, which perhaps will be quite matching with what Professor Hajra says, is the differential interferometry DLNSR, what we call, and relatively new concept of persistent scattered interferometry, alternatively called as PIS also, which is extremely useful in monitoring the surface deformation, including land subsidence, coastal dynamics, and slope stability, etc. I just cited a small example few days back. Ministry of External Affairs wanted to know some information about the Vasanchar you might be knowing, which is very famous these days. It is a small evolving island in the, like in the, what we call the Yamuna estuary region. And this large number of rehabilitation has taken place there. The migrant refugees has been taken there. There is a report that the Vasanchar is subsiding due to this anthropogenic activities. So somewhere or other we could manage to have this persistent scattered interferometry. I came to know that what is the spatial scenario of the surface deformation. These are very extremely useful sensor. When you have nothing, at least you have some first-hand information. Apart from this remote sensing satellite, nowadays these location-based services are catered by the GPS satellite, even our own constellation, that is IRNSS, NAVIC system, what we call it. Extremely useful in navigation, mobile application, disaster management, aviation, as well as in the transport industries. Especially the NAVIC is designed to provide the accurate position information with an accuracy of plus minus 15 meter to the users in India, as well as in the region extending up to 1500 kilometers from its boundary, which is we call as a primary service area. If you look back the last year during 2020, that is during COVID-19 lockdown, it has taught us many lessons. Although there are a huge loss of life and economic slowdown, but we have witnessed the natural cleansing of the earth due to cut in anthropogenic emissions. This has given us a unique opportunity to study the earth system processes under controlled anthropogenic condition and the present impact on that pristine climate. Today, there are diverse sources of earth data freely available to the users community at different spatial and the temporal scale. But too much data, to my understanding, also sometimes creates a noise. It is imperative when we are doing the climate change study to understand the quality of the data, because the magnitudes are so subtle. When you say, someone says about the sea level rise anomaly or sea level rise is some millimeter, maybe a 2 or 3 millimeter, you can understand the level of accuracy. And not only the accuracy, uniformity across the globe is a very, very important. So that means the quality data, when you talk about the climate, it is not that I take a sensor without calibrating with other sensor and straight away announce that this is the magnitude of the sea level rise or glacial melt, absolutely ruled out. My second thought always, which always bothers me, by doing someone but 20 or 25 years study and people jumps on the conclusion of the climate change. We have to be very careful using the word climate change. It's always safe to say the variability because it is basically interannual variability. We should not jump on by 10 or 20 years that climate change is happening, as well as we don't have that much consistent data, accurate consistent data, to culminate to some, the kind of conclusion. So we have to be very careful in making some conclusions. Keeping in view all these constraints, especially the quality, climate quality data, in ISRO made a venture and a program called NICES, National Information Center for Environment and Climate Studies. The 64 biological products, biogeophysical products rather, are generated using 16 sensors at different temporal resolution, ranging from 30 minutes to 1 year, to have a central repository of the qualified climate data set. So I am saying this thing, that is the reason, because this is our own data sets. Rigorously, it has been checked, as well as it is generated by our own team, own scientists who are technically qualified enough to generate the product. All are their own subject matter specialists. And now almost 23 years data are available in the public domain to make use and have climate change study. Still the far way to go because it is just 23 years is nothing, but well, it's a good start. Now, besides this space and airborne sensors, a relatively new introduction of UAV, all of us we are knowing, and the drone that has revolutionized the sensing platform because it is feasible, cost effective, and real time. You need not wait for a satellite pass kind of thing. You need not wait for the pass. The time you want, you can immediately fly it and get your data. UV with the nano sensors and more endurance will be in the future of remote sensing at the local stage. That is what my understanding is there. Now we are all seeing that there is actually data. It is everyone is pouring data, and there is a flood of data. Every hour data, different sensor, different sources, data is there. As there are several sources of data over a large period of time, the mammoth task is to process that time series data to get a trend and the hot spots of the change. Here comes perhaps the MLAI, which will not only generate the various scenarios, but also significantly reduce the human intervention, because everything is going in the automatic mode these days. Automation is the word of the day today. Today, most of the digital classification also, if you see that these are mostly MLAI based, and it is proved that mimic cognitive human intelligence is capable for much more classification than statistical parametric based classifications. The another emerging area of use of internet is IoT. It is where billions of physical devices around the world are connected together. All are collecting and sharing data. Thanks to the arrival of the superchip computer chips and the ubiquity of the wireless networks, now it is possible to turn anything from something as small as pill to something as big as aeroplane into a part of the IoT. Now, connecting up all these different objects and adding sensors to them adds a level of digital intelligence to devices that would be otherwise dumped, enabling them to communicate real-time data without involving a human being. The Internet of Things is making the fabric of world around us more smart, more responsive, merging the digital and the physical universes. So I will conclude by saying that to fulfill the dream of digital world and the aspirations which has come out from this conference, we need to integrate several technologies, a component of ICTs like remote sensing, GIS, GPS, MLAI, and IoT. And exploring the social relevance is the most important point these days, that what I am generating, whether there is a demand from the user side or I am just doing